好，如果参加受过敏的人就进会场吧。
Okay, so I want to urge the audience to come to the venue.
现场就这么多人了，然后剩下
I think that's all pretty much for our offline audience, and I have already sent the online link to our friends, and we have altogether 500 quota, and the registration is for free. And so now I want to extend my sincere thanks to all the audience online and offline. And the topic today for this breakout session is food allergen. Because we know that the allergy is caused by certain materials or substances, and that's why we translate that into allergen. Well, in Chinese, it's 过敏源. And we know that the allergen is the reason for the allergy. Now, I from the China National Center for Food Safety Risk Assessment, or CIFSQ, you already know about our center. And we have a sponsor, which is the Roman Labs. And its a parent company is Disman. In the middle, they have another company name. The co-chair is the product manager of Roman Labs division holding. His name is Martin Rodrigo Candia. I'm very happy to co-host this meeting with him. After my presentation, I will hand it over to the co-chair, Martin. Afterwards, I will come back to moderate the roundtable session. Okay, so that's all for our arrangement. Okay, so now I will start first. Okay, so I will start my presentation. Before I start my presentation, I could review the topic, which is still related to allergen. And I covered this topic last year and year before last year. And my question for you is whether allergen is a mandatory labeling. And when did China's food allergies regulation transformed from voluntary labeling to mandatory standard? Are we ready for that? And last year, I said it was coming soon, yet it is not with us yet. It's fair to say that all the procedures have been completed, and the review committee, the subcommittee of labeling to the secretariat, all the approval procedures were completed, and we are one step away from the official issuance because we need the co-signature from different authorities. As long as the co-signature is finished, the regulation will come up soon. And because this is more about administrative procedures, it's not about the technical issues. So now I want to talk about the food allergies regulation in China, from voluntary labeling to mandatory standard. Speaking of the allergens, be it voluntary labeling or a mandatory standard, we have very important legislations regarding it. Monetary definitely is the good practice and the purpose. We will monetarily require the labeling of 8 main types of allergens. While for the rest of the allergens, it's for voluntary labeling. And we have now the 8 new categories. While for the new categories, the beans were excluded, while the sesame is included into it. But also there are some exemptions. For instance, if the soybeans were produced into oil, it is exempted from the monetary standard. And also for the soft phosphatide, if it is content, it's also mandatory for its labeling. I think the most important solution to prevent allergy is the information disclosure. It may create very devastating health impact. One piece of peanut could claim a life. So a very effective way is to prevent allergy. Therefore, we need to use labels to avoid the food allergen. And some special substances should also be avoided, such as the sulfites and gluten, protein. So in the prepackaged food, such food should be labeled. Previously, some audience asked us if there's any monetary labeling in the catering industry. I think, according to my knowledge, the answer is no. Yet in the US, they will still have such clear labels as milk or peanut included in the menu. So here you can see that from the Codex in 1985, the food allergen regulations was already started. And then in EU, in Japan, in the UK, and in Canada and Korea, respectively in 2000, 2002, 2004, 2008, 2010, food allergen labeling became mandatory. While in China, in 2011, the allergen labeling was included into the food labeling recommendatory range. Yet, it's just a label, and we do not have a harmonized labeling management system. For instance, for exporters, if they want to export their products to the US and to the EU, they need to follow the requirements of the customs for validation. And FDI will entrust Chinese customs to label the allergens, and they will further validate the labeling. While back in China, a lot of businesses don't do that. Some multinational companies want to do that, yet some say it's a voluntary labeling, and businesses start to identify that some potential allergens were included, and the auditors or the regulators published them for such instructions. Therefore, a lot of businesses tried to avoid such troubles, and they want to give it a try and wait for monetary standards. All of these is due to the lack of coordinated and harmonized labeling management system. Therefore, in China, it's necessary to promote the allergen management system and to translate the voluntary requirements to the mandatory labeling is very important. And now the technology is not mature in this area. And also you can see that in 2011, referred to GB 7718 and listed 8 major allergens. And so you could remember that they refer to the materials or the allergens that may cause allergy, and they can leave it to the choices of the consumers, while the producers can also voluntarily decide which to label. And by saying that it may contain or it contain the small amount of certain allergens, etc. So even if you think certain substances is included and you already recorded, but you didn't do that.
Actually, the recorded products in Europe is the products without any indication of allergens. Our investigation, and lobsters and fishes are most probably resulting in allergies. Previously, we had some enzyme products, especially Xinjiang will cause some allergens of the poor people, and the enzyme can be regarded as an allergen. In this November, the CPPC conference in Guangzhou we will publish standard. So in the process, we can find that the pre-packed products we have published general rules for food safety national standard, and it required compulsory. It provides compulsory requirements on December 14, 2018. The 8 allergens can be divided into 8 categories, and the non-protein element can be exempted from labeling. And the rest substances can be labeled voluntarily, but the 8 categories must be labeled. And currently, we have finished the administrative work, and the National Health Commission planned to sign the standard, but only one ministry or organization cannot decide on this, and they need the joint signature on this standard. The risk assessment depends on science, but the theory depends on policy as well. So these are the 8 critical allergens. peanuts, nuts, shellfish, wheat, fish, milk, eggs, soy are the old 8 categories. The new standard will base on the 8 old categories, and also there are some allergen exemptions: refined, bleached, and deodorized oils, cultures, and enzymes produced by fermentation process. We will strictly assess enzyme agents for wheat derived glucose syrup, dextrose monohydrate, maltodextrin, and sugar alcohols, as long as the protein are extracted, it can be accepted. And so these are the 8 categories, the big 8. Since they contain natural proteins, they are heat resistant to proteolysis, resistant to extremes in pH. So usually major proteins of the food, and food can have one or many allergens. So the main proteins in food fall into the big 8. So from 1 to 8, many different proteins can be involved. So more than 160 food documented to cause food allergies. But these are not exhaustive. The prevalence, severity, and potency are different. Internationally, CIFSQ Codex was developed in 1979, amended in 1983. By CCNFSDU, CCNs defined gluten-free conditions, thresholds, and analytical methods. In 2008, it was amended again. In amendment happened in 1999, the Big 8 are defined as the major allergen sources based on recommendations from expert consultation conducted in Rome with FAO in 1995. The global guidance on food allergen labeling was approved by CCFL. The major allergens and ingredients from the food need be indicated in the pre-packed label. It was based on the expert consultation in 1995, that is the severity levels and the list of allergen sources. And actually this list is based on majorly the white people. So finally, it resulted in different labels and lists in different countries on the basis of the Big 8 plus plus a highly variable list of ingredient exemptions and variable tree nut species. And for each species, there is a list, altogether 8 to 18 of this kind. Countries enacted labeling regulations to enforce declaration of priority list allergens, and we also use the old Big 8. So the low-level residue require some methodologies, testing methods to identify their residues. Last year, CIFSQ published the production specification, and voluntary precautionary labeling was expanded. And the Big 8 voluntary list and the voluntary labeling formed our system, which is aligned with the international codex. The Big 8 has been established for 22 years. After the FAO expert consultation, it has been used for 26 years. Scientifically and clinically, the labeling control, theoretically speaking, experienced significant changes. Many new information was generated in the process. That is to say, this year, or last year, we organized the FAO WHO expert team risk assessment consulting committee, which consists of 20 experts from Canada, the US, China, Thailand, Argentina, etc. And a professor from China Agriculture University, and from another organization represent China to be a member of the expert team. The first meeting held over 3-week period was started in late November 2020, and summary and conclusions of first session released on 10th May 2021, full report released in summer 2021. The expert team conducted the risk assessment, and the Codex committee need to further consider the food labeling, because the old Big 8 and the new list are different. The soybean is removed from the old, and the system is added to the new, because a lady on airplane died after eating the food with sesame. So finally, the committee thinks soybean is not a very serious allergen. So we can see in the new list, milk, eggs, fish, crustacean, shellfish, peanut, tree nuts, cereal sources of gluten, and sesame are incorporated. The scientific works has been done, but the scientific transformation in lab is not finished yet. So here in our national standard, the soybean is still there, and so the old list is used in our standard. The ingredients, the raw materials, and some substances which cannot be removed can be indicated. The allergen safe product, and the consumers could choose by themselves, and stakeholders need to take actions. The food industry should provide sufficient information to consumers, and also the producers need to educate the consumers. The government need to adopt legislation, and of course they should take the responsibility of education. Actually, they are in China, and the industry has the intention to label the allergen, but the extent need to be considered, and also the consumer's preference in terms of language and the consumer's appetite need to be compulsorily considered.
Preferences of the consumers. And for instance, we need to use the terminology that are familiar to the consumers. The wording is very important in the lists, and also we should consider the quantity that need to be identified on the labels, including the evaluation clinically. Maybe we don't have a very stringent requirements in this area. We believe that the best practice is to have precise standard and the random double-blind oral agent volume. And that's the reference dose. According to the international experiences, we have the vital 3.2 reference doses. And here you can see there are some reference doses for these different allergens. For instance, within an egg, it may include 8,900 milligrams of protein, while the allergen, especially critical allergen, only account for about 0.2 milligrams. Therefore, we use 0.2 milligram as the benchmark to calculate the reference doses. So you can see that for peanuts, it's about 0.2 milligrams. Now, 7.8% of them have the labels, while the labeling part will increase the proportion of risks. And it's the same for beans. And then we can further identify the concentration. And for instance, according to the level of vital 2.0, most companies, be it mandatory or voluntary, their labeling is not qualified. Actually, theoretically speaking, if it's above this threshold, that should be labeled mandatorily. It may be related to a flour, ingredients, the sauces, and also the other relevant materials. Maybe previously for the flour, you need to identify the wheat within it. That is to say, if egg or the wheat is contained in it, you need to clearly label that. In all the labels of the allergens, it's very important to prioritize the labels. And for the US, they have also included the sesame, while in Canada, sesame was already included early on, and it was also not included in New Zealand, Australia yet. Yet in Japan, you can see their priority allergens. Altogether, there are 6 ones. So different countries have their different priority allergens. And they may also have their own different procedures, how to effectively manage the system. We should think about the cross-contamination cleaning and test in 2020 in the Codex Alimentarius. We have the allergen management guideline for the food producers, and the food producers need to follow the CIFSQ guideline. And in different countries, the priority allergens are different, and they have such practices based on the evidence-based process to mandate labelings of ingredients. As I already mentioned, that it should be lower than the placebo-controlled food challenges. For upon the positive double-blind ones or unequivocal reports of reactions with typical features of severe allergic and intolerance reactions. And here you can see this is the standard of Europe, the priority allergens. They have the crustaceans and sesame seed and glutens, while in Canada, you can see that they have also included the glutathione. And for China, we don't have it yet. We also have Vital, which is a very great risk review tool. And we should think about from the raw material to the processing to production and labeling. In this whole process, the most important thing is that we need to identify the categories of allergens, the doses, and also the correlation between the quantity and the different types of allergens. And based on this, we can come up with the detection method, and then we can know there are different methods. For instance, the genome or DNA-based tests or detection method, and also protein-based detection method. The latter is a more important means in deciding a food recall. For instance, the peanut oil, you can only identify the essence, the material, not the quantity. We also need to have the evaluation method, for instance, SID, etc. And lastly, I want to say that for different periods of time, the paper published regarding food allergens was quite different. In the past, we had quite a few published papers, and gradually the published paper in food allergy is on the rise. Now we almost can rank #1 in this area. And different institutions are also working on the food allergens. Just as I mentioned, the FAO and WHO food allergen risk assessment conferences, or also in the CIFSQ, we also have some similar sessions. We do need the laws and regulations for the regulation. We also need to control the allergen and the detection methods. Thank you so much. I'm quite behind the schedule. And now I want to hand it over to the co-chair the senior manager, Martin Kandia, the product manager of Allergen.
Thank you very much.
From Roma
I just need
Labs
a
division.
second because I need to deactivate my translation. I'm not sure whether I'm listening live to what you say, so I hope you can listen to me. Okay.
Yes, Martin, now it's for you to share the session. Yeah, please go ahead.
So, entire screen. You should be seeing now my screen.
Yes, we can see the screen.
So, good afternoon there, everybody. Thank you for having me. I would like to greet you all in the name of Romalabs, and I would also like to thank you for the opportunity to present once more this year the CIFSQ. I will try to keep my talk rather short. We're a bit out of schedule, so I will focus on make just a short and brief discussion on priority allergens and non-stressful levels. If by at any moment I am speaking too softly or too fast, please stop me, and I will make sure that to repeat whatever I say. So, as we saw just a couple of minutes ago, labeling of allergens is quite diverse all over the world. So we can find actually the core of allergies are shared between countries. Those are what we call the big eight, namely crustacea, cereals with gluten, fish, milk, egg, legumes like peanut and soybean, and peanuts. Now, in many other countries, we will find some other way more diverse allergens, like for example, crab, the Japan factory. We also have in Europe where we include some other allergens like mollusks, here. We also include, for example, celery. There's also lupin, and then we can, of course, have the case of Australia and New Zealand, where also Polish and Royal jelly are included. It's quite diverse. And here I have just mentioned really mandatory allergens, but if we extend this to voluntary, then we can find even more in the case, for example, in Japan, where we have peach, we have kiwi, among many others. So we found that the list is quite diverse, quite long. Nevertheless, where that list really come from? I think we have already mentioned it in the presentation, but basically we all always talk about the big A and the big A allergens that account for around 90% of the reactions in the globe. Nevertheless, there's a bit of a history behind it. So just before moving on to the new priority allergens and stressor levels, I wanted to recount a little bit this. So in the early 90s, there was no there was actually quite a problem when it comes to labeling of products. There was not much of explicit allergen labeling, but in the Codex standard, in the general standard, 1985, so after the 1990s, we have this rule that we informally called like the 25% rule. This rule basically was applying for composite ingredients. And what this rule meant was that only sub ingredients of a product that would amount to more than 25% of the final product require labeling manufacturers. This actually brought the industry into an awkward situation in which if you had an allergen that was present as an ingredient in more than 25%, below 25%, you should actually label it. But if this allergen was actually in the same amount, present in the same amount, but as part of individual sub-ingredients, then you didn't need to declare it. So basically, one had to declare the component, and the consumer would have to decide what was safe for him to eat. But nevertheless, this would actually mask a lot of allergens and made render the whole labeling actually quite ineffective. Furthermore, there were many problems in which, because there was not a need to declare many of the components of the composite ingredients, then we would have, for example, just labels saying extract of herbs or herbal extract or similar, and that we wouldn't know what exactly is there. And in many cases, it might be that there was allergen masked there. So that was quite problematic. It was tried to be revised a couple of times, actually, but finally, and it was around 1993, there was a proposal to the Codex Commission of labeling that was brought up. Basically, the peer's head was Norway, but was a collaboration, actually work with other Nordic countries like Finland, Iceland, and Sweden. And what they did was actually present a paper to the Codex Commission where they discuss hypersensitivity. They discuss also which were the foods that were causing this, and some other issues, and how this was actually a risk for the consumer. So the Codex Commission treated this paper back in 1993. And basically what they were proposing was focusing on the change of the 25% rule and the declaration of potential allergens in food. Yeah. Now the treatment started there, but as we saw before, it was quite some time until this actually was adopted. So it was 1999. So we can see that it took 6 years for the Codex Commission to actually adopt this into the standard. So we have an amendment in the Codex. And what happened was that in the meantime, there was a call on a consultation of experts, an expert panel. And this expert panel basically reviewed the available data with what's quite meager at that moment, what quite restricted. There was not much data. So it was really based mostly on expert opinion. And what they came out was with this list that we call until now the Big Eight. Yeah, namely cereals containing gluten, egg, milk, crustacea, fish, tree nuts, soybeans, and peanut. To be completely truthful here, the 8th was actually sulfites. I have not included just basically because it's not an allergen. So peanuts and soybean were just packed together into leggings like peanut. But anyway, we take only the allergen sales amount to 8. Yeah? So this was basically incorporated back in 1999, and since then has been basically the standard core of allergens that have been adopted for most countries. So what actually happened when it comes to so here we have the actual Codex change, and we can see all these allergens, and also the fact that derived products were also are also there included. So what happened actually when it comes to regulation? We are talking about the first proposal in 1993. Then, can you hear me properly? I'm having feedback that the sound is very poor and there's an echo. So maybe if the people from our organization could try to check whether they can take care of the echo. Thank you for the feedback to the public. I will try to keep my mic as close as possible so that it maybe take care of that. So I'm sorry. I clicked on the wrong button. So what happened with the adoption by countries actually? So we saw that the first presentation was in 1993. The Codex was amended only in 1999. And it was not only until 2003 that actually the European regulation changed that with this new labeling regulation, basically, which actually was not put in place until 2004. So it was even longer than that. Actually, the end of 2004. So the actual application could be said to be 2005, actually. Yeah. So it's quite a long time that takes to be to this, all these things to be taken into place. Yeah. Nevertheless, what we saw is that the European regulation not only took the 8 allergens, but actually extended the list. They extended it to 14 allergens that included this time also sesame. They included mustard, mollusks, lupin, and celery, besides all the others. Yeah. And most importantly, the European regulation does actually do provision for exemptions. Um, that is to say that it is possible, there is a mechanism for which the manufacturers can ask for exemptions for particular food deriving from allergens so that they do not require labeling. Of course, this has to be proven that there's no allergenic risk for these foods. And furthermore, and most importantly, a difference regarding what was in 1999 the codex is that there was then the three nuts were specified in the case of European Union. So it was not just simply saying tree nuts, which actually caused quite some troubles down the stream. But the European Union actually specified which tree nuts these were. Following year, there's the Food Allergen Labeling and Consumer Protection Act in the US that was promulgated there. They included 8 allergens, the 8 original allergens from the Big 8. They also do provisions for exemptions, and they also specify in this case the tree nuts. Nevertheless, there's a big discrepancy between the tree nuts from the US and the European Union. The US includes way more tree nuts, including some foods that are not really tree nuts. They just have nuts in the name, like for example coconut. So it was quite a big difference there. We have then after this that many other countries also followed, not necessarily in this order. I'm just showing chronologically these 3 examples that I will show, but there were many countries that started adopting it. We have from every continent, actually we have the case as we have seen from Australia and New Zealand. We have countries in Latin America, in Asia as well. And in Europe, we also have some examples in which individual law was actually adopted. We saw already in the previous presentation in 2011, China does the first or regulates for the first times the labeling of allergens there. They are including the same 8 allergens as FALCPA, but the big difference, and I think it's not notoriously that has to be mentioned, is that of course this was not mandatory, but it's only voluntary. Yeah. So this is a big difference. And as we all know, this is, of course, moving to a mandatory. So what is then to be done? Yeah. Some other notorious improvements regarding the labeling is the fact that it was not only a problem about labeling the individual allergens, but actually how they are labeled. Yeah. In many cases, we have the example before, as I said, the herbal extract. Also, in some cases, for example, dried whey would not necessarily include milk on the side. And there might be some people that actually do not make directly the association of dried whey as coming from milk. So this was a problem. So we have moved forward a lot in this sense. There was a big improvements regarding labeling. We now have, again, many varieties in all around the globe. But in generalized, this has improved. We have now, in many cases, the fact that the allergen in discussion or that is content that is being contained by the food has to be also, for example, explicitly written and also in bold letters. That's been adopted in many places. Funny enough, there's a mistake here. For example, it should say wheat and not gluten. Yeah, but nevertheless, one can see still a huge improvement in the way manufacturers are labeling their products. Now, what's the current situation? We saw a little bit of this already in the previous presentation. Basically, last year there was a big improvement, I would say. So, and it's the development of a code of practice on food allergen management by the Codex Alimentarius. And why do I say this? Because one of the big problems, the main problems that the manufacturers had, is that allergens had to be declared not only if they were a main ingredient, but also if there was any chance of being contained in the product, also in traces levels. Yeah, this is actually part of what was discussed originally in 1993, when the content of allergens as sub-ingredients was actually treated, because many of these composite ingredients can actually already contain could be second or third generation ingredients, and they could already contain allergens. And therefore, it is really important to make this kind of control and to cover and assess the risk about that. Furthermore, you all are familiar already with risk assessment on cross contact of allergens. So this is something that the customer, the food producers were already applying for a long time, and this was actually developed during the past 20 years. So it is really, really important that the Codex actually finally developed a code of practice to help also to give some guidance on this subject matter. So the actual objective of this code of practice is, as I mentioned, provide a guidance to the manufacturers to actually apply, all these policies and procedures to identify the allergens in all of the areas of production, and to implement effectively an allergen management plan. And as we can see here, there's basically 4 controls that should be included. Basically, the prevention and minimization of any potential allergen cross contact that might be a risk to the consumer that has a food allergy. Also, to minimize the potential presence of undeclared allergens being present in the food for any kind of errors or effect in the supply chain. We also see that the code of practice is supposed to ensure the accurate information that can be provided to consumers, but also, and importantly, to ensure the correct labeling, allergen labeling on prepackaged foods. So this is also important because then this touches the general codex standard about food allergen, so food labeling. And this is then what happened when the commission that was formed to come through to develop this code of practice came to this point. Then this was also taken into the food allergen labeling committee in Codex, and so that's how the commission was formed. This ad hoc FAO WHO expert consultation started. We saw it already started by the end of last year. And basically, these experts are being consulted on risk assessment of food allergens on 3 big points. We already saw there was one, the first part that this was supposed to review. Well, not only was supposed, but they actually reviewed the priority allergen list according to risk assessment. They also review and establish thresholds levels in food of the priority allergens. And finally, there's a third part that is meant to review and establish precautionary labels in foods of priority allergens, which is, as we saw before, actually quite a big problem in the industry. We saw great attempts to standardize this, in particular in Asia Pacific, in New Zealand and Australia, by the Vital Group. The Allergen Bureau is doing a great job there. So what came out of it? Well, for the first part, which was the review and the validation of the priority list, they basically took 3 criteria that is very, I think it's very crucial to mention here. It's very important. And it's basically that they analyze the actual scientific data that is available regarding prevalence, but also about severity of the allergic response of the individual allergens, of the allergenic individuals eating this food. That means what kind of reactions they are having. Are they mild, moderate, are they severe? And also, as we saw before, the criteria for including these individual, the studies where this data came from, what was quite stringent. So actually, it's quite good. And finally, the potency of the allergen, namely how much allergen is needed to elicit a response. Yeah. So these three criteria was quite explicit. All the data and all the information I'm giving in this presentation is available, readily available on the Food and Agriculture website. So what came out of it is basically that they provided several lists. The first is what they have called a global priority list, basically a priority list of allergens that is supposed to be valid for countries all around the globe. And it basically contains the same allergens that were before, but with some major changes. So we have there again gluten containing cereals, wheat, rye, and barley. Notoriously, there's no oat mentioned there. Oat's not included in that list. Yeah, important change. We still have crustacea, egg, fish, milk, and peanut. But when it comes to legumes, so peanut was included, but soybean was not included anymore, was removed from the list. And this was, and instead we have a new player coming into the scene, which is sesame. Furthermore, and this is also important, when it comes to tree nuts, Codex has not left anymore an open interpretation. This time they have, I'm saying Codex, this is not Codex yet. This is actually the expert consultation, yeah, that was done for the Codex committee. So they have basically analyzed data and found that there's enough data to focus on 6 main tree nuts, namely almond, cashew, hazelnut, pecan, pistachio, and walnut. Nevertheless, they have made provisions for what we could call a second priority allergen list, and this is based on individual countries according to regional consumption. As we know, there's a big variation. There's many changes when it comes to prevalence and also patterns of consumption and patterns of allergenicity. Sorry. Yeah. So which population are allergenic to one or the other allergens? So they have made provisions for this, and they have actually recommend a list of allergens that could be considered also for priority lists in the individual countries. This, for example, we can see buckwheat. This is actually quite a prevalent on Asian countries. So you might be already familiar with the Japan regulation that already includes it. For example, we have also celery and lupin. These are known to be, for example, way more problematic in particular areas of Europe, but not in others. Also, not in other regions of the world. So they have been left here in this list. We have also here mustard, and notoriously oats and soybean that were removed from the priority list has been included here. So and some other specific nuts, tree nuts like Brazil nut, macadamia, and pine nuts. So basically, now they have put on a region basis and country basis also the responsibility to review also these other priority allergens. Furthermore, there's a big inclusion that I think is actually quite nice because it shows already a view in the future, and is what is about possible future allergens. So the Commission has actually accounted for the new trends in alimentation, the use of way more plant-based proteins, the use of insect proteins as sources of proteins. So they have actually established what we could call a sort of watch list. Yeah, basically they have listed pulses, insects, and some other food, like for example kiwi fruit, to be monitored regarding prevalence, regarding the occurrence of allergenic reactions and their severity, so that in a future review they can be considered or not for inclusion. So this is also important because I think it shows a way more proactive attitude, so to say, in the sense of a general and much more periodic revision of these kind of things, which is definitely necessary because the food pattern does change quite a lot and is changing quite a lot in just the past 10 years. So they have also already there listed the the possibility to evaluate in a case-by-case basis allergen-derived ingredients, just so to make room for exemptions. Like we can see, we saw exemptions already listed before, like for example in Europe, where refined oils do not need to be, for example, alcohols coming from some cereals or from some nuts, then they do not have to be declared, and so making space also for some others exemptions. So the second part also already took part. The first one I didn't mention, but it was there on the picture. It took, the first report was actually issued on May this year. So the second part was to review and establish the thresholds for these priority allergens that was determined on the first part. So basically, they were to determine what are the threshold levels, which so below which the majority of allergen consumers would not suffer allergic reactions. What would be appropriate analytical methods for testing not only food but also surfaces, so environment, and what should be then the minimum performance criteria for these analytical methods. Yeah. So this second part already also was finalized. So the summary conclusions were issued on August, so just 2 months ago. It's quite recent. And basically, what we have gotten is a list of thresholds, namely actually a list of reference doses recommendations for the 8 priority allergens that were mentioned in the first part. Most importantly, here all these reference doses as based on data that comes from TNO and FARP, and this I think is actually quite relevant, because this is the most comprehensive data that we have right now. This was originally published by the Hooven and Remington, which were also part of the commission reviewing. Sorry. He also, in the case of Remington, for example, he's also part of the Vital, the expert panel, scientific panel that advises Vital. So I think there's quite a big recommendation there. So we can see that new reference doses, these reference doses are based on the eliciting dose of allergens that would cause an allergic reaction in less than 5% of the allergic population. Yeah, so what we call the EDO5. And so why the EDO5? Why was this taken? Well, according to the data that is available, they have analyzed not only the data published, they are included for these values, but also the ones that was left aside. They have made an analysis of bias that was actually included in this data. And basically, what they came to the conclusion, they have come to the conclusion that in this level, the kind of reactions that was observed was mild or moderate, that there was no adverse really strong adverse reaction, and more particular, there was no anaphylaxis or lethal observed at all in this range. So they have considered that this was actually a safe limit to start with. And then they actually analyze how this would affect portion sizes. So they made like a panning from 10 to over 500 grams of portion sizes, and see how these reference doses then would be practically applicable with different analytical methods. So this is the reference doses they came from. And not only we have now reference doses for almost all the allergens that they have listed, but we see that all of them are pretty much at the same level, except for crustacea, except for one from shrimp. All of them are around 1 to 5 milligram of total protein. Here is also important to notice that it's not an individual allergen, it's not allergenic protein, it's not allergenic source, so it's milligram of total protein of the allergenic source. This is also really important because the Commission makes a strong suggestion for all countries to adopt these kind of measurements. So the unit is referring to allergen of protein, total allergenic protein. They also make a big call about the need for reference materials for all these allergens. And they assess that actually the current analytical methods are suitable for this, but there's a lot of deficiencies still in the methods. We all know, not only because of the lack of reference materials, and that brings about problems regarding the comparability of methods, but also because there's a lot of misunderstanding, or maybe not comprehensive understanding of the matrix effects that the different methods of analysis have. So what's next? There's still a third part to come, basically reviewing and establish precautionary labeling in foods and predatory allergens. The Commission is still to review which methods are available for this, and also to try to provide some guidance on precautionary label and how the threshold that have been set could be applied. Yeah. So just maybe one thing I didn't mention before. So milk and sesame do not still have a level, and furthermore, the one for almond is just provisory. Yeah. So this is still an ongoing work. Yeah, but they already have a first list, so this is actually quite helpful, quite useful. And as I mentioned, there's the third part coming that would be focusing on PAL, that is precautionary allergen labeling. So what does it all mean? All these recommendations have not yet been adopted by Codex. This is really important to understand. So these are recommendations that have the expert panel have done. So they are still to be evaluated by the labeling committee to decide whether they are adopted by Codex or not. But if they are adopted, then all countries that are actually signatories of the World Trade Organization would have to adopt these new guidelines. Also, region-based evaluation of the priority allergens list would have to come. We already see a great work here on the Chinese on the side of China, so it's really commendable to see this. And we need to pay also attention to, if we take a look at how history has developed, we see that all this can actually take quite some time. So the first, as I mentioned before, the first discussion started in 1993, and only until 1999 Codex was changed. And furthermore, and once the Codex was changed, it took like almost 6 more years, or 4 to 6 years until the countries followed. Yeah. So this doesn't mean that every country will have to change legislation overnight, but they would have to at some point actually adopt these things. And when it comes to analytical methodology, well, we have it's clear that we have a need for better comparability, on different methods. We all know the issues. We know that, for example, antibodies used on different methods are a big source of variability. We know that there's a need for reference material, and we need more clarity also on how to interpret what the unit means, what the result means, what are the recoveries on different matrices for different methods. Yeah, so there's no panacea for this, and a toolbox approach in which different methodologies are actually applied would be the go-to approach. So with this, I close my presentation. I have also stretched, actually I was trying to be a bit faster. In the end, I took the time that was allotted to me, but I'm finishing a bit over the time. So thank you very much. And then I would like to continue to introduce Sabine Baumgartner. Sabine is a professor in the University for Agriculture and Biotechnology in Vienna, in Austria, actually. We here simply call it BOKU. Furthermore, she works actually in the Institute for Agriculture in Tulln. So without further ado, I would like to introduce and to keep the microphone to Sabine. I'm stop sharing you. I hope you can see Sabine now.
Thank you very much, Martin, for that really nice introduction. Good afternoon to all of you from Austria. It is really...
The public can hear you?
Can you all hear me?
Yes, we can hear you. Yeah.
Oh, perfect. Thank you very much for that information. So, good afternoon. in that case, directly from Austria, it is a great pleasure for me to joining you at the Chinese International Food Safety and Quality Conference. And in that case, virtually, I'm really looking forward to next year in that case. So thank you for the organizers to giving me the opportunity to give you a short intro and some information about what Martin actually ended with to some test methods. And as we from the analytical point of view also always like to standardize our methods, I want to show you what's ongoing in the European Union with standards actually for allergen measurement. So I will start with some information about test methods in use and the analytical targets we have there. And after having a look into the methods, I will switch to regulations and standardization in Europe. And actually, I will sum up with a short overview about the suitability and capability of the methods, as well as some, as Martin also already said, some still existing gaps and needs for the determination of food allergens. So let's start with the methods in use and the analytical targets we have. So actually, out of that enormous pool of analytical methods we have, there are only 3 which are in use for the determination of food allergens. And we already have the consensus that the total protein is the base of the clinical determined thresholds. But first, having a look at the allergenic food itself, which contains, beside fat, carbohydrates, and fibers, also DNA and total protein. The allergenic proteins are part of the total protein. So for the determination of DNA, the PCR or polymerase chain reaction measures specific DNA sequences. And ELISA and mass spectrometry are the methods of choice if proteins or peptides are measured. So similar for all methods is the use of a conversion factor to recalculate the measured results back to total protein, whereas for the measurement of DNA, an additional translation step from DNA to allergenic food is necessary before we can apply that conversion factor going back to total protein. More details for the DNA-based methods. So the specificity and also sensitivity of the DNA-based methods results actually from the measurement of the desoxyribonucleic acid, or as I've said in short, the DNA. This method is dependent on specific identified and selected primers, which are actually published in literature. Due to the specific primers, the methods have the capability to measure multiple food allergen-specific DNA sequences. Therefore, it is possible to run multi-screening assays with these methods. And there are, as for all methods, and as it was already mentioned, some really special restrictions. As for example, the quantification limits are sometimes high. There is no differentiation between beef and milk, or for example, egg and chicken possible if we measure the DNA. And DNA is not equally distributed within the food. However, the main disadvantage of PCR is that it only provides evidence of DNA presence from an allergenic food, and therefore there is no direct information on the allergen or protein source respectively. So this means that the obtained results always need, as already mentioned, an additional translation step in between. Second method, the immunochemical methods. The immunochemical methods, especially the enzyme-linked immunosorbent assay, or short ELISA, are capable of measuring epitopes of selected allergens or total proteins. Those antibody-based techniques, such as, in that case, ELISA or the rapid ones, the lateral flow devices, have been extensively developed by researchers targeting mostly a single food allergen. They are nearly for all food allergens, which are included in the existing labeling regulation, ELISA kits commercially available. So in literature, a lot of different setups for immunochemical methods can be found where the procedures are published, but especially for the commercial kits, the different used extraction buffers, calibration reagents, and procedures are well kept secrets actually due to intellectual property rights. And what all methods have in common are that they differ, as Martin already said, in the quality of the raised antibodies and the used antibodies. And therefore, the results may vary among commercial brands and also different batches. And they also suffer some method restrictions, as already shown before, for the DNA-based methods. And this includes, for example, matrix effects or insufficient extraction of the protein, which is measured, insufficient specificity, which can come up due to cross reactions, which can occur, and also sometimes insufficient reproducibility of results. But compared to the DNA-based methods, these results we get by immunochemical methods are directly convertible to the already mentioned clinical thresholds as given in total protein. Due to all strengths and weaknesses of DNA-based and immunochemical methods, the call came up for alternative methods. And scientists always want to check usefulness of their methods. And that can only be confirmed by complementary methods. And that actually was the hour of mass spectrometry. So mass spectrometry measures peptides from selected allergens. So this bottom-up proteomic approach starts with the digestion of a protein mixture, which is followed by the separation of these peptides by liquid chromatography. And further on, the mass spectrometry analysis of these separated peptides is done with the following corresponding chromatograms, which lead to the information of the intact peptide masses. So this information can be broken down to the single amino acid, which means that sequence information of separated peptides is obtained in that case. And also the mass spec methods are characterized by different steps, which make the method usable for food allergen measurements. But due to the use of the actually very sophisticated technical and expensive equipment, it is even more challenging. So the steps in between comprise of the setup of the targeted screening method itself, corresponding to the used instruments, because there are actually a lot of different mass spec instruments on the market. And also extraction needs to be optimized, as well as the digestion procedure. And the marker peptides for the different allergens must be chosen. And as also done for the other methods, there needs to be a quantification procedure and a method validation procedure, which needs to be set up. So in the last 10 years, actually different mass spec instruments, separation methods, and specific food allergen peptide sequences were permanently published and reviewed. As long as the food allergens, or in general, allergy was coming up into our view, the scientific community started in parallel to develop the different methods. And legislation and official controls started with a certain delay in that sense. So since December 2019, the regulation on official controls is actually in Europe fully applicable. So the regulation covers food and feed safety, plant health, and animal byproducts. So it actually provides a coherent approach towards the official controls along the whole agri-food chain. And since 2019, there is also a regulation for an information management system for official controls in place. So this regulation includes rules for the rapid alert system for food and feed, which is very important because there you can see everything about withdrawal or cases which come up, also for the allergens, not only for the allergens. The system for notifying and reporting information on animal disease is on the way. The system for notifying and reporting the presence of pests in plants and plant products. The tools for administrative assistance and cooperation, and additionally, the trade control and expert system is within this regulation ongoing. We already heard, especially for food allergens in first instance, legislation has foreseen now the labeling regulation. We have seen that in the two talks before, and especially for Europe, the food allergen labeling regulation is in place since 2011, and as we've heard from Martin, probably there will be some changes ongoing on that, but this is the version which is actually at the moment on the way. So this regulation provides the rules for food information to the consumers. And in Europe, it includes the 14 food allergens or food groups when they are used as ingredients. So non-ingredients, for example, food allergens in food due to cross contact, are not covered by this regulation. And there are also no regulatory thresholds given at the moment, except there are two exceptions in there. There is on the one hand gluten, for example, with 20 milligram gluten per kilogram food if you want to declare it as gluten-free. And although sulfites, as Martin already mentioned, are not real allergens, they are regulated in this regulation, and a threshold is given there with 10 milligram per kilogram sulfites actually. And I have to admit that there was no further legislative development until now, but probably the world is always moving, as we've heard from Martin. There will be some movement in that case, I think. Although there was not much from the legislative side, normative responsible persons worked on different levels of standards because, as you know, also we scientists always want to standardize methods, as also Martin has said before. And if we have a look in Europe, there are in each country different national standardization bodies at work. And for Europe, there is the European Committee for Standardization, where the national bodies are members and can have, according to the working groups in ZEN, corresponding mirror groups. As for example, this is done for the food allergen or the food allergen working group. And the European Committee for Standardization has an agreement for technical cooperation with the ISO, the International Organization for Standardization. During the Vienna Agreement, which was signed in 1991, it was drawn up with the aim of preventing duplication of effort and reducing time when we prepare such standards. Through this involvement of experts in those technical committees, actually, European and national expertise is being developed and also recognized globally when we have a look at the ISO. So what happens on basis for the food allergens? So there are only a few general documents actually available. There is one technical report which is published and offers a template actually for supplying information about immunological methods and molecular biological methods. And there is the standard EN 15842 out there, which specifies how to use the standards for immunoassay, nucleic-based acids, and chromatographic methods, and the relationship in the analysis of food allergens. So it contains mainly method validation requirements, definitions, general definitions, requirements for setup of the laboratory, description of the methods, and test reports. So this document specifies in general guidelines for the requirements and use of reference materials, also for the determination of allergenic commodities in foods. So, and here the term reference material actually within this document includes certified reference materials on the one hand, as well as quality control materials. And what is also stated within that standard is that there are currently only a limited number of reference materials out there. And as soon as new materials become accepted and validated, so which is an important point here, they can be appended as an annex to this document. And this document does actually not deal with the sampling issues. So it simply details processes which are involved from receipt of the laboratory sample to the end of the result and how the result should be expressed. So you see, quite general standard which is out there. For the DNA-based methods, there are five parts out there. So where the first part of EN 15634 is again the part with the general considerations which are given. Then the second part is already made its way into a European standard, whereas part 3 and 5, as you can see here, are at the moment under approval. So that means they were a technical standard. That's what the TS actually stands for. They are moving from a technical standard now to a full standard. And those 3 are under approval at the moment. So each standard, as you can see here, deals actually with a certain allergen within a certain food. In that case, it's celery or mustard and soy in cooked sausage again. So you see so it's not spanning the whole list of our allergens we have here when we talk about those standards. For the immunochemical methods, it looks really a bit different. So there is only one standard actually existing there, which is again part 1, which deals again with all the general considerations about immunological methods. And as you can see here, there is only one or 2 technical standards actually out there, again for hazelnut and immunoassay determination. Unfortunately, as I've already shown you before, they used, and in that case really all validated immunochemical methods, which we need for those determinations, are commercially available kits. And I've told you before that this is the reason why these methods did not overcome the hurdle from a technical standard to a European standard, because within these kits, the different used extraction buffers, calibration reagents, and procedures are intellectual properties actually, which is not compatible with a standard going out there. And therefore, 2013, when this technical standard actually came up, the procedure came to a halt in that case for the immunochemical methods. And as mass spectrometry still is in its infancy for food allergen measurement. Method standardization is in that case also still scarce, but nevertheless, as you can see here, EN 17644 is at the moment under approval. And again, here we have a document for general considerations for the detection of food allergens by liquid chromatography mass spectrometry methods. So we will see what will be in there when it is published after, and I really do hope it will be approved. So you see there it is an overall framework for qualitative and quantitative mass spec methods. So for the determination of specific peptides and proteins, and there is a general guidance given and performance criteria, as Martin already said, which we definitely need for methods to apply these methods for allergen measurement. And as this is the first method here, I'm really first standard actually here. I'm very curious about what comes up next with all the changes we probably have in labeling regulation and with the methods moving further on, also here in the range of the mass spec methods which are used for food allergen detection. So just let us sum up now and give an overview still about methods, suitability and capability, and as Martin also ended up with, some gaps and needs, especially for our method development and measurement we need. We do have three very, very powerful methods for the detection and measurement of food allergens, with all the pros and cons these methods actually have. But we are far away from covering the whole spectrum of food allergens. And as you see, it is always developing. There are always new allergens coming up. Some are disappearing because they are not that necessary anymore. So you see, we are always, from the analytical point of view, 1 or 2 steps, or even 2 steps behind. So this work is still in progress and ongoing, and as long as data, and especially also our necessary clinical data we need for that, for the calculation of reference doses, will be set. So sequence information is published or will be published, and once in a time a set of reference materials will hopefully be available, as this is also in discussion, as you have seen. And although we still find the current paradigm, as there is no existing guidance for the capability of our methods for the detection of food allergens before actually regulatory limits are enacted. But I think our methods, or all the methods, have nevertheless demonstrated very, very well that they can cope with the task of food allergen trace analysis, as Martin has shown the list before. And I have to admit, these methods demonstrated their capability, but there is still a huge amount of transdisciplinary research necessary if we want to move on further in that case. So there are, and there will be, always gaps when that issue is moving forward. So for example, as Martin said, there are still no appropriate reference materials out there for our method comparison. So I'm really, really looking forward to that. So also standardization and exchangeable expression of units for results. That discussion, as you have seen, is still ongoing. And also the standardized calculation of method performance characteristics is on the way, I would say. There are only a few determinations of method performance characteristics in multiple food matrices, and the performance of analytical methods for detection of different forms of allergenic food is still ongoing. And what is also ongoing in case of the standardization procedure, there is one standard under drafting at the moment, which is a European standard for foodstuffs, which comes up with minimum performance requirements for quantitative measurements. And you see you can see the long list here, what is actually included. So it starts with milk, egg, peanuts, and you can see here also the different tree nuts are mentioned here. So starting with hazelnut, almond, walnut, cashew, pecan nut, Brazil nut, pistachio, macadamia. It is wheat in there, lupin. We also find sesame, mustard, soy, celery, fish, mollusks, and crustaceans. But this is as a standard under drafting at the moment. So you see, the food allergen story will be continued. So we are going on with that story, and I hope, or I'm quite sure, that there are a lot of more chapters to this story to be added, actually, from the scientific point of view and also from the regulatory or legislative point of view. A lot of chapters to be added. Many, many thanks for your attention. It was a great pleasure sharing with you my presentation.
Thanks， 小白。我们下一位报告人是张大伟，他来自于罗曼的无锡实验室，他主要毕业于暨南大学，然后长期从事真菌毒素的工作，最近混到过敏院来了。然后，那么我们主要的一个，因为实验室嘛要做出证报告，所以无麸质食品这一块，今天主要他要讲讲这些方法，好吧？
非常感谢还在会场的这个嘉宾啊，我参加这个就是过敏原论坛的话，到今年已经是第5届了，已经从这个乙方做到了甲方，然后呢，这个判的这个标准出来判了5年了。今年呢，确实由于疫情的影响，是参加会以来最少的一个。本来呢，我的介绍呢其实是这么写的，就是呢叫罗马实验室张大伟，江湖人称大老师。但是呢，吴老师给我开场呢，我不能叫大老师了，那一定是小学生，对吧？行，我今天给大家演讲的题目呢是这个谈一下我们的这个麸质过敏原，这个有这个 R5的抗体和这个 G12的这个抗体，这个不同的这个方法。哎，好像点错了。哦，对，可能是按错了。好的，第一个呢，就是讲一下这个麸质过敏原的这个前世今生，就是因为可能很多人还不是特别了解这个麸质过敏原，比如说我们为什么要这个制定麸质过敏原这个限量标准啊，包括我们要对这个过敏原进行管控。然后第一个呢，就是这个麸质过敏原，其实它是根据这个可溶性来分的，就是指的其实就是纯溶蛋白，就是溶解在这个乙醇当中的蛋白，主要是呢这个 prolamine 和这个 glutamine 这2类。然后呢，它们呢占总蛋白的这个80%以上。第二个呢，就是比如说我们谈这个麸质蛋白啊，我们要去做这个检测的话，其实我们检测的是什么呢？比如说像这个小麦当中呢，我们检测的是这个纯溶的这个蛋白。然后呢，像这个就这2类的话，分别比如说在小麦、在这个燕麦、大麦，还有这个它代表的这个就是这个蛋白结构是什么样的。还有一个呢，就是其实很多人会问了，就是说，那我们比如说我们可以，比如说我们的食品当中，我们就直接是无麸质食品，我们把这个 gluten 去掉不就好了吗？其实 gluten 的话，它在我们的这个食品当中是有很多的一些应用的，就是可能它是有一些，比如说食品当中是必须要添加这个 gluten， 比如说呢，它这个有一些物理化学性质， 它有助于这个面包的这个质地和这个形成。还有呢，就是比如说作为添加剂，它可以用于这个低谷物的这个蛋白的这个产品。还有就是它可以作为这个增稠剂和粘合剂使用。还有呢，就是它谷蛋白凝结的话呢，是乳化和形成这个结合的这个水。因此呢，这个 gluten 呢，它其实是我们这个在我们的这个食品的这个工业中，或者在我们的这个日常的这个风味口感当中起了很重要的这个作用。然后呢，但是呢，它有一个问题啊，就是说对于这个就是对于 gluten 过敏的人来说呢，它会就是有一种反应，就是刚才吴老师也谈到了，叫乳糜泻，就是我们叫 CD 这个反应。它呢主要是呢，第一个就是它是一个消化系统的这个疾病，免疫介导的，然后它主要是由于你摄入这个麸质而导致的。还有一个呢，就是它这个会有这个遗传性的，就比如说你的这个，比如说家族当中是有 gluten 过敏的，那有可能你的这个小孩或者子女的话，它会有这个 gluten 的这个遗传。还有一个呢，它主要的就是引起这个小肠绒毛的这个凸起，然后呢就是破坏。第三个呢，就是世界上呢大概有1%的这个人口呢是受这个疾病的这个影响的。最后呢，就是说对于这个过敏源的话，我们有一个这个话就是。如果你想要就避免这个过敏的话，那唯一的方法的话就是不食用这种食物，这个是对于所有的过敏源都是适用的。然后呢，这个呢我就不去详细介绍了，就是说它这个如果对于这个乳糜泻的话，它的一些症状是什么样的。第二个呢，我们就讲一下这个麸质过敏源的这个检测方法吧。检测的话呢。刚才的话，我们很多的这个专家教授都讲过了，我们就不去详细解了，主要就2种嘛，一个是基于 DNA 的，一个是基于蛋白的。那基本上呢，就是 PCR 的方法、LC-MS 的方法，还有这个试剂盒或试条的这个方法。但是有一个问题啊，就是我们去跟这个企业或者跟我们的这个客户去交流的时候，大家很多时候会问一个问题，就是说对于这个过敏原检测有没有金标准，就最好的方法。其实呢。我呢，对于其他的过敏源呢，不敢说有金标准，但是呢，对于这个麸质过敏的话，它是有金标准的。它的这个标准的话，就是试剂盒的方法。那我可以给大家讲一个这个之前的一个碰到的一个故事啊，就是前一段时间呢，有一客户问我，他说那个你们能不能检测这个食品的过敏源麸质的？那我一想，哎，我们这实验室就专门做毒素和过敏源，正好撞到枪口上来了，对吧？那我就跟他开始聊，他说呢，能不能出这个 CMA 报告？那我说不行啊。因为什么呢？因为我们其实看到了，我们这个试剂盒的这个方法都是内部的 in-house 的方法，它是没有就是我们的这个国标的方法的，你是没办法去盖这个 CMA 或者 CINAS 这个章的。那我就没事你放吧，我就继续讲故事。我说是没有办法去盖这个 CMA 章的。然后呢，他就跟我说，他说不对啊，我之前给一个实验室做的，他们就给盖了这个 CMA 的章。那我一会儿给大家看一下。然后呢，他就把这个报告发给我了，我看了一下，它是一个我们就是原来出入境的一个标准 SN-T 的一个方法。它这个方法呢，我们可以看一下，它的这个就是检测线的话是0.01%，然后这是它的这个方法，它是一个荧光 PCR 的方法。那这个方法的检测呢，其实它的这个就是说它给的这个检测线的话就是小于0.01%，那这是什么意思呢？我们来对照一下啊，就是各国的关于这个麸质，它是就是唯一一个现在有限量标准的。那我们可以看到，无论是低麸质产品还是这个无麸质，它的这个标称的话都要小于20个 ppm。我说举个例子，什么意思呢？就是比如说我们都知道，比如说我们去景区，说是小孩子如果超过1.2米或者1.3米，你要去买这个半票，对吧？低于1.2米的，你就不用买半票。然后呢，你做了这个检测呢，就好比说你拿了一个说。证明说我这个孩子低于2米，你拿这个给人家，其实这个证明是一点用都没有的。所以我们就说这个客户呢就花了钱测了个寂寞，对吧？电脑卡。然后呢？所以呢，关于麸质过敏原的话，其实它一定是有金标准的。它现在的这个标准的话，其实我们 Codex 上面也是写的很明确的，那它就是这个试剂盒的这个检测的方法。 然后呢，就是因为各国的这个法律法规不一样啊，就关于这个过敏原的，就是肤质过敏原这个检测呢，有几个就是要素要跟大家强调一下。第一个就是它是任何的这个就商业化的试剂盒都可以使用的，比如说你希望做这个无肤质的宣称，那你这个就是检测线至少要小于20个 ppm。第二个呢，就是它没有限制特定的抗体。第三个呢，就是呢，根据这个法典委员会的要求啊，它指定的呢就是用 R5的这个抗体，然后呢做这个无肤质的这个宣称。它这个 R5的抗体指的是啥呢？指的呢其实既不是这个 G12的抗体，也不是 R5的这个抗体，也不是这个快速的这个 R5的抗体，指的是这个R5的这个抗体加上这个就是他们叫鸡尾酒的这个提取液啊，这就是 Codex 上面写的这个方法。所以呢，那这个因为我们其实都知道 Codex 的这个方法呢是1979年去发布，然后1983年改版的，包括到后面去进行了很多的这个改版。其实关于这个肤质过敏原检测这块的话，它一直没有更新。但是呢，就随着这个后来科技的进步啊，那我们 Roma 公司呢，在这个2000年初的时候呢，就做了一款这个基于这个 G12的这个抗体的这个试剂盒。那所以的话呢，我们今天的这个主要内容就是想讲一下，就是关于这个 G12和这个 R5的这个抗体，它在这个就是整个比较是有什么样的不一样？比如说它设计的这个理念，包括它的抗体啊，包括它的这个检测方法。那这个呢是一个总的一个关于抗体这边的一个概述。我们可以看到 G12的抗体呢，它的这个主要的这个肽段呢是截取的是这个 QPQLPY 这一段，也就是我这个图上标出来的，在这个右上角的地方 G12的这个抗体。然后这个 R5的抗体呢，它主要是这个 QQPFP。然后呢，它呢基本上都是可以检测这个小麦，然后大麦以及这个黑麦的。然后呢，比如说我们的这个 G12的抗体呢，对于燕麦呢，它会有一些很低的这个交叉污染，然后呢，它这个存储条件有一些这个不一样的。然后呢，它这个 G12的这个抗体呢，它的这个设计呢，主要是什么呢？就是我们刚才说了，你关于这个乳糜泻的话，它的这个毒性呢，主要是使你的这个小肠凸起，然后影响你的这个消化系统。然后它呢，就是截取了这个一段这个就是氨基酸上的一个特征的一个肽段，所以呢，它呢相对来说呢，更加直接的选取了这个毒性的这个肽段，然后去做这个试剂盒抗体的这个设计。然后这个是大概的这个就是 G12这个抗体的，就基于 G12抗体的这个试剂盒的一些技术参数吧，比如说它的这个标准曲线啊，它的这个原理啊都是三明治的原理，然后它的这个检测线，包括它的这个定量范围，以及它拿到了这个 AOAC 认证，是有一个这个标准的这个方法的。然后呢，下一个呢，就是我给大家呢列一下，就是说关于这个 R5和这个 G12啊，就是它在检测的这个步骤上面有什么不一样的地方啊？那对于这个我们做这个试剂盒检测都知道，它基本上是2大步嘛，一个是这个提取的步骤，还有一个呢就是点板的这个一个步骤。提取的步骤呢，我们可以看一下，我把所有的这个不一样的地方用红色的标出来了。那个第一个不一样的地方就是我们 R5的这个方法呢，它指定的是这个要用这个 cocktail solution， 它这个 cocktail solution 它是有专利的，所以呢它没有就是说给定这个就是里面的这个成分啊，包括那个它这个 cocktail solution 是拿到这个专利的。那其实呢，这个因为我们就是做这个一行的，其实我们的这个 extraction solution 和 cocktail solution， 它其实里面有一个就是其实都加入了这个球基乙醇，就应该说从这个配比来说的话，它其实是差不多的。所以从这个你看这个它的这个提取方法来说的话，唯一一个区别就是一个稀释倍数的一个区别，一个是1:12.5，一个是1:10的这么一个稀释。然后我们再到后面这个方法来看啊，它基本上的话，其实它的这个点板的方法的话也是大同小异，那都是三明治夹心法的这个原理。然后去清洗，可能我们的这个清洗的时间次数要多一点，然后我们的这个敷育的时间要稍微短一点。所以，然后最后呢，就是因为它这个 R5的抗体呢，它检测的是这个叫 醇溶蛋白，也就是叫 gradient， 所以呢，它这个 gradient 大概呢是占这个就是总的这个 gluten 的大概是100，所以它在最后结果计算的时候呢要乘以2。那我们的这个呢，已经直接把它放到了这个整个的这个公式里面去，所以你如果直接带到公式里面去的话，你最后得到的那个结果，那就是说你检测的这个 gluten 的这个结果。那讲了这个，也就是说这个整个检测的流程以后呢，我们再来看一下这个我们的这个结果的比较嘛。这个结果的比较呢，有一部分呢是引用了文献，后面我会列出来，还有一部分呢是我们公司的一个内部的一个技术文件。那这一块呢，我们可以看一下，就是它做了不同的这个机制之间的一个方法的之间的验证，比如说做了这个婴幼儿的这个早餐，然后做了这个就是早餐的这个玉米片，然后还有一些这个就是所谓的这个快速食品啊，然后包括酱油什么的。那基本上呢，我们可以看到就是它的这个整个的这个结果的话，比较出来的话还是非常一致的。然后呢，第二部分呢，这个是我们内部做的。我们内部的话呢，就是它每一年的话都会参加这个 FAPAS 有不同轮次的这个关于过敏原的肤质过敏原的这个验证。我们可以看一下，基本上它的这个结果还是比较一致的。比如说这个阳性和阴性的这个比对，那结果一致。然后它的这个最终的这个定量的这个结果，就是这2种方法其实也是一致的。所以呢，讲了这么多呢，我就引用一下这个文献当中的最后的一个结论吧。文献当中呢，它就是比较了一下这个 R5和这个 G12的这个抗体，那最后得出的结论呢，就是这个 G12的这个方法和这个 R5的这个方法，就是它做了很多的这个验证啊，最后结果的话是一致的。然后而且呢，就是可以作为这个过敏原的这个检测的试剂盒的一个合适的一个方法。然后这个是一个文献，它这个呢是这个由一个奥地利的这个学者去做的，所以呢，它不是我们公司自己发的这个文献，是一个评价了这么一个2种抗体基于抗体不同的这个方法之间这个结果的一个比较。然后今天的这个演讲的话呢，基本上是到这边。然后呢，最后一个呢，放了一下这个就是个人的这个微信，因为其实我们前几年讲的这个题目就是关于这个工厂的这个过敏原控制。跟工厂过敏原控制的话，因为他在这个甲方嘛，基本上的话，就是对这方面还是比较有经验。然后呢，今天呢，可能我们希望会讲的这个低效一点方法这个，所以呢，如果呢大家有任何关于这个过敏的这个就是问题啊，就是客户上，然后给大家。
我们从无锡到中国，从中国到亚太。那么我们下面请罗曼的亚太这个总经理，这个呢廖永威是吧？廖
应该是 IIO。好，廖永威。那么廖经理要给我们介绍这个ISO 导致17025实验室的服务如何为食物致命原的防控带来价值。廖博士是美国加州大学工商管理的 MBA 的并且获得了康奈尔大学的食品科学乳品培训的项目证书。在很多领域有较深的造诣，大概有8年的专业经验，现在是亚太区的总经理。那么下面有请廖永威女士来给我们做报告。
Thank you very much, Professor. I'd like to start with the value in terms of ISO 17025, so a quick one. The agenda I would like to cover today will be 4 big items: preventive control from US food monopolization law. This is for food manufacturing, and how do you do the cleaning regime that earlier Professor Wu Youning was talking about. And from implementation, the customers who approach Roma Labs, what are the services and Roma technical competency that we help the industry in Asia. And last but not least, I'll cover the verification in terms of how the food production in Asia are using verification method to actually ensure food allergen could be detected and declared properly in the label. So I'd like to start first thing on the US Food Safety Modernization Act. As you can see here, a lot of the preventive control from the US regulatory right is clearly showing that allergen control, you must start from cross contact, and which is what is mentioned by Professor Wu Yongning just now. And it's very important that we take note. These item that we do preventive control actually clearly states that if the allergens are associated with raw material, you must make sure that there's no allergen cross contact in the recipe itself. And you can see segregation is one area that we can segregate the allergen control. So storage condition will be segregating the raw material and also handling the potential incorporation of the allergen when you run the recipe. So the next step also show again another production scheduling that you can allow you to actually minimize the risk of food allergen in production. And this cross contact, right, if you do not allow yourself to actually have a separate instrument, then definitely there's always a cross contact. And this risk is actually very high. And I'll show you the procedures that you should follow in order to make sure allergen is in control in the subsequent slide. So here is a sanitation control. So a lot of the allergen control in the industry is all about sanitizing. The principle of sanitizing, the validation that you need to do on sanitizing. Sanitizing is everything in allergen. So I would like to share with you, how does a diagnostic kit Roman Labs provide help you to actually validate the sanitizing principle and procedures. And later on, I'll show a quick update on the procedure itself. Besides that, please take note in the sanitization, right, you need to know the hygienic zoning. So later I'll share with you what is a hygienic zoning in terms of zone 1, zone 2, zone 3, zone 4. And in the validation study, how do you actually ensure if you are doing a sanitation, please use dedicated cleaning utensils. So these are very simple things that we can do to make sure you have a good validation. So another very important part is besides US food modernization law requesting us to ensure allergens are being in control, GMP today, if you are a food manufacturer for GMP already mandate allergen as one of the very important cross-contact contamination reduction. So first step, you also must have GMP cert, and the GMP also require you to control the cross-contact for food allergen. Now I'm going to show you a customer here that really approaches Roman Labs to actually look into soy, and it's a soy formula milk powder that could be contaminated with casein. Casein is an allergen. So soy milk powder contaminated with casein. So in order to do very good cross-contact validation study, first thing you must see whether your material is actually spiked with the casein and the casein allergen could be traced or not. So here there's a study by the multinational company who approached Roman Labs. It's a very, as you know, BP formula is very complex for soy type of recipe. So soy being a complex matrix, right? The first step we should do is whether the kit is working. So can you trace the problematic recovery if you are looking at spiking it? So we actually spike the casein based on the procedure given by the customers to us. What we did is that we offered our casein ELISA kit, which is the Agrocon Plus kit, and we showed the result to the customers and actually help them to understand whether the kit is actually able to recover the casein allergen itself. So we actually did a low, high, and three different recipe, 3 different soy recipe. And we found out that in recipe formula number 2 and formula number 3, on the high spike, the recovery is much better. So according to the customer here, recoveries of high spike was better than the manufacturer's customer's expectation. So in other words, we have actually found a kit that can actually do the cleaning, sanitization, validation. So this is a very important first step for all food manufacturers. And next, in the BRC context of actually doing cross contact, it is also written very clearly. The best practice is that you actually have to find a spike that can work for the actual allergen, and then you actually put it into a finished product and trace. And after that, you do a deep cleaning, because in the deep cleaning, you can see whether you are removing the casein itself and minimize the frequency of the product changeover. If you can do it, please try to minimize the crossover recipe. If you cannot do it, then please do the next step. The next step means this: if you have already found the analytical test, for example, just on the Agrocon ELISA kit that is working for the spiking. Then now you can carry out the validation of a cleaning already in order to minimize the casein left over in the production run. So in order to do this, right, you need to do validation. After validation, then you need to do verification. So I'll show you right now what does a validation means. For example, this is a production factory. You have milk as an allergen for recipe A. Same production line, you change to B, recipe B. Recipe B has peanut, and peanut is also an allergen. And then after that, you do a cleaning and then you change to recipe C. In recipe C, maybe you will not have any allergen according to your formula, but you would know that you will have milk carry over, peanut carry over, and likely at the point when you do the recipe D, when you introduce egg again, it means that you have egg coming in. So at the end of the day, right, when you are actually doing the validation for sanitization, control of a sanitization, you need to look at recipe E. After recipe E, which is the most complex one with milk, egg, peanut, you find this sanitizer whether you can clean out everything. So you use the most complex recipe to do your validation first. And that's when you actually do a proper study using an ELISA kit, because it's the most simple kit to use in the market. So when you do this, you need to know where are you sampling, because you're doing sanitizer to control, right? So sanitizer means you need to see zone 1 is clean out or not, zone 2 is clean out or not, and even is contamination to the phone, to the locker, whether they are being cleaned out. So most likely, most people will actually sample this site, zone 1 and zone 2. And in the zoning process that you have for zone 1 and zone 2, the very important manufacturer should use is the swab. And this swab is actually very important. It has to be validated against the ELISA kit that you're going to validate for the cleaning. So you will do a direct swabbing, and sometimes you will also send the rinsers, actually take the rinsers out to check whether you are casein residue, for example. And sometimes the rinsers could be called CIP rinsers. So you have surface sampling from direct, surface sampling on rinsers, and you also have product sampling. And very important, product sampling is not just finished sampling. For validation or cleaning sanitizer, you need to use semi-finished product sampling. And these 3 types of samples, if you have a capability to run ELISA kit locally in your factory, please do. If not, then you can also send to Roma Labs, ISO accredited laboratory to help you. So this is very important in the validation. In terms of doing the right analytical test method to do this cleaning validation, earlier I mentioned you probably have to use your finished product to spike it to see whether you can recover it. Then you can implement this sanitizer recipe in order to help you see whether you're cleaning out. So determine the cleaning and disinfectant residue present in the sample matrix is highly, highly critical in all factories who needs this allergen control. And usually in the market of Southeast Asia, as well as Korea, as well as Japan, a lot of the factories, food factories, actually engage a contract laboratory with ISO accreditation 17025 to help and assist them during this very critical stage of sanitization validation. So what do you do? If you have a testing on the product, you will see ELISA being recommended. So ELISA kit will be the best currently available, not too expensive, able to send to a lab for testing. But for surfaces, right, for the verification, you'll do a lateral flow kit. But you need to do ELISA as a first step because you need to validate whether the sanitizer is working. So you need to see before and after cleaning whether the ELISA reading is going to be lesser and lesser, which I'll show you an example shortly. So very important in Roma, we've been in the business to support many customers in allergen control. We want to mention a very important thing. During the validation, please do not use any swab. You should use the swab that is validated against an ELISA kit. For Roma, we have an alcohol ELISA kit. We have this swab that we sell, which is our swabbing kit. And this swabbing kit is validated very well with our ELISA kit. So we can always use this swabbing kit to actually swab for peanut, soy, and all of them is actually validated against our kit. So it comes in 20 kits at one swab boxes. 20 of them, shelf life is very long, goes to 12 months, and you can store it at 15 to 25 degrees Celsius. Please use validated swab. Please use validated swab. This is very crucial. And in the procedure of helping many customers in the region, we have 4 laboratories in the entire world, 1 in each continent, 1 in Singapore right now. Austria, we have 1 ISO 17025 lab as well. UK, we have 2 laboratories. And then in US, we have 1 laboratory. Actually, in total, we have 4 or 5 operational laboratories in the world. And in China, WuXi, right, we are already expanding it with CNA's accreditation for allergen. Once it's available, we'll have our own WuXi laboratory to help customers in China. And we provide all the testing services for allergen, from finished product to rinses to swabbing to also the semi-finished product, which I'll demonstrate in a short while. Here, how do you do a food producers in order to do this cleaning regime? Validation is recommended at least 3 times. For every validation cycle, you need to do 3 replicates, in other words. And you have to do it in the different seasons, sometimes in winter season, one time in summer season. You have to monitor the seasonal effect as well. So as with this respect, 3 repetition is very important for us. And please do not just do it on annual basis, because if you look at the change in your recipe, as long as you change recipe or introduce a new recipe production line, you need to do the entire validation one more time to see whether the sanitizer is working. So customers ask us, Yonghui, what would be the best methodology? There are different types of dedication of equipment to do the allergen risk control. But please take note, the worst scenario is always the mixed recipe. Like earlier I mentioned, milk changing to egg and egg changing to peanut, for example. Mixed recipe is the worst type of combination. And if you run it simultaneously within one production line, it's even worse. In this case, you need to do 3 product sampling per run to do the validation for cleaning. And then you also do the swabbing and the rinses as well. So this is a typical scenario that we encountered the entire Asia, sending samples to room labs in Singapore. One very important thing is before you start the validation, you should also monitor whether your recipe is actually a homogeneous product or not. Some customers told us they are not homogeneous because their peanut is actually in granular form. So in this case, it's not heterogeneous. It's not homogeneous, it's heterogeneous. In other words, you need to do visual inspection during the validation, and maybe you have to strip down the nuts and bolts of the equipment to see you actually clean out the peanut granules. So this is one very important challenge we're experiencing in Asia right now. And if you look at the entire allergen map, you have swabbing in different zones. And you take note, you need to swab at least 2 to 3 samples per surface during the validation. And you need to go after grooves or crevices that the residue may remain and your sanitizer cannot reach to. And that is the usual problem that I encountered during any recall. So take note, when you swab, please swab the grooves and surfaces when the sanitizer may not reach easily. Next, you must also do the rinse, because you need to know rinse 1, rinse 2, rinse 3, whether the allergen content really being removed out in the rinses. So please also collect the rinses. Again, 2 to 3 samples is needed. After you do the rinses, you need to collect the samples. So this is a very typical scenario. A customer sent us all the samples from the different location of the factory to Singapore. And then they'll tell us this is before cleaning. And we'll do the ELISA testing. We'll get a reading like this, for example, 7.6 ppm on the peanut hopper. And as you clean rinse number 1, you see a result from the swabbing that we received also in Singapore before and after. We can tell the customer, yes, after the rinse is non-detect. So customers usually send us 1 rinse, 2 rinse, 3 rinse. We'll see the reading, and sometimes at the 3rd rinse, then you see a non-detect. Later, I show you an example. So this is a very typical validation that they send samples to a contract ISO 17025 laboratory. Whole of Asia, everybody do almost a similar method here. So take note, you need to swap them. You need to send the rinses. You also need to send the semi-finished product to the laboratory for testing. If you can do it on-site with an ELISA reader, it will be the best. And if you look at the food production, when they actually do this cleaning, how do they actually, after confirming that rinse number 3 works or rinse number 2 works, how do they actually verify every recipe change? That's when you will use a strip. So strip is actually the final control whereby you have already validated the recipe. It can clean the sanitizer. The sanitizer can clean out the allergen. Next, every allergen crossover run that you want to remove the cross-contamination, you need to do a verification with Agra strip. In this case, that Roman Lab, we offer the Agra strip to the market. And this will enable you to control and minimize the entire allergen risk to the 0 level, for example. And one very important phenomenon in the market is there's always a problem how do you see 20 milligram or 10% allergenic powder falling onto the floor compared to 200 milligram or 1% allergenic powder? So this is typical scenario that we see in the production line. So what you will do is this, you still have to make sure in any case after you validation or the sanitizer successful, you still have to every day do the lateral flow, which is the agua strip in this case, to really check whether whenever you have spillage, you are able to control it. Spillage can be of different concentration, different sanitizer may be used to clean up, but you need to verify on the spot. 10 minutes, you'll get a result from the lateral flow kit. So this is highly important. It verifies every recipe change that is a control to make sure that you do not have allergen residue to contaminate the next recipe. So Roma actually for allergen for agua strip in this lateral flow kit, we can actually use it for product, we can use it for swab, we could also use it for liquid product. So you have this very important tool to help you. Next, I want to show you a very important global customers who have ice cream production in Australia, and they needed to declare their ice cream dairy free. That means no milk. They'll declare in the label no milk. So how does a dairy-free company works? Dairy-free company will actually look at different recipe and did an operational LOD. So they send us many ice cream tub into Singapore, our ISO accredited lab in Singapore for Roma. We actually done the limits of detection for each recipe run. So we can actually calculate for them whether the LOD is working for them. So this is a result. They send us recipe 1, which is an ice cream bar, recipe 1, recipe 3 times. Remember just now I mentioned you need to do 3 replicates. So these 3 recipe, right, they were sent to us in an ice cream bar, and we actually do the ELISA method using our aqua quant kits in our laboratory, the milk kit, and we run, and we can see that the result for recipe first time round 1 0.06 ppm. Round 2 is 0.13 ppm, round 3 is 0.06 ppm. So it looks like from the operational LOD standpoint to declare dairy free, the best ever lowest they can go to is 0.06. So this limit will be staged in their facility. They will check against this every time they run the ice cream bar to declare it dairy free ice cream. Now, you look at the dairy-free chocolate. They also have a chocolate recipe to declare dairy-free. That's when they send us the ice cream tub again, and we actually run 3 times, 3 different recipes. They run 3 times. They send us we send them the result after we tabulated in our laboratory. The results are quite high, which is different from the ice cream bar that is without the chocolate. You can see the result 0.09, 0.084, and 0.009. Sorry, 0.9 again. So this is at ppm level. So to the customers, this is not desirable because it's quite high. It means that adding the chocolate, it brings the LOD higher. So in this case, they need to clean more for chocolate recipe, and they need to clean to the level of 0.06. So the detection limit of study here for Roman labs in Singapore is very crucial for the customers because they can use this data to implement in the production how they would be able to declare dairy-free for the ice cream itself, even it's chocolate or no chocolate. So I just want to tell everybody here, very important, ISO accredited lab can help you in monitoring the limit of detection for dairy-free ice cream. And the outcome here is that customers set a threshold value, and that will trigger a clean action in their facility. This will allow them to claim the dairy-free in their labeling regulation of their product, and also ensure they have an allergen risk mitigation strategy. Next, I want to show you another very important validation we have done to manage the cross contact. This is a case study we do in Singapore with our Singapore customers. They actually send us a very important oat milk. Okay, and they actually extract the milk over from the oat. And in this case, the manufacturer produced this as a UHT recipe. They have 2 production lines. Why? Because they produce the oat milk extraction first, and then they'll bottle it in the local OEM manufacturer. So they have 2 different production helping them to complete the whole process. And they want to claim that the oat milk is soy-free, casein-free, and BLG-free, beta-globulin-free. So what they do is this: when they engage Roma, right, in the analytical service laboratory, they send the oat milk first time, semi-finished product, And then they'll send from the local OEM bottler the finished product for us to test. And they'll also send us all the rinsate that they clean out. So in this case, Roma helped them to actually make sure that have the LOD discussion throughout the beginning of the extraction of the oat milk out before they actually bottle and after they bottle. So this will allow them to actually claim that it's actually soy-free, casein-free, and BLG-free. It's all data-driven, scientifically driven with our ELISA kit in our laboratory. Next, another challenges we face in Asia, very a lot of spices. So how do you make sure spices are not with allergen? So we have a customer over in Singapore, in Asia as well. They send us a sample, and this is what they do. They rinse it. So again, they do a validation on sanitizer. These customers, they get a different concentration on liquid chlorinated alkaline cleaner. They send us a swab after the first rinse. So they swab after the first rinse, okay? Then after that, they run the same concentration of liquid chlorinated alkaline recipe because they want to qualify this alkaline chlorinated recipe to be the sanitizer to be used. They send us a second swab on the following day after the second rinse. And here is the result. You can see here, the different stop, for example, the knife scoop, the beaker, the hopper, the mash, the blender, they send us different swab and we help them to summarize the result with our ELISA kit. We can see for the first rinse, right, it improved onto the second rinse when they are looking for peanut. So we found out that in the blender, after the second rinse, we'll see a lesser than LOD. That means not able to detect, less than detection limit. So in this case, the blender in the second rinse is the best. So with this result, they will implement the second rinse throughout the recipe run whenever they are changed over, and they will look for peanut with the agar strip because agar strip lateral flow peanut will be the verification to help them. So validation use ELISA, maybe a laboratory will help you with ISO 17025 accreditation, but for verification, it's always a lateral flow kit. So hope you can clearly understood the different collaboration that we work with customers. So in summary, ISO 17025 laboratory are very crucial to collaborate with all the manufacturer recipe owner. Ingredient testing is not everything for ELISA for allergen control. You must implement the sanitization control and the qualification. You also need to know that the production step including heating, whether it will affect the recovery of the ELISA kit. So that's when the first step you should do is to spike it to see whether the allergen kit is able to recover. Efficiency of sanitizer can also be validated against the ELISA kit method. You can use the rinsate as well to help you monitor whether the reading is coming down. And operational LOD is a new phenomenon in the market that we'd like to share with everybody here. If you're claiming dairy-free, milk-free, please make sure you do an operational LOD with your laboratory that you trust and also a ELISA reader that if you can implement in the production floor. And testing of cross-contamination is very crucial. For example, for spices, seasoning is very important. And with that, right, we actually did a lot of support in the region because we have been doing this analysis for so long. We actually published 3 IAFP poster this year in 2021 in the US. IAFP is a very prestigious conference, so we published 3 different posters because customer asks us, sometimes I don't have time to validate everything. Do you have a poster to share that your agua quan milk is working, for example? So we actually tested different chocolate recipe in the market that we can buy from Singapore, and we test with our agua quan milk in our facility, in our laboratory, and we actually found the labeling requirement when they label with milk or no milk. Actually, the result is actually very, very consistent. So we'll be sending this PowerPoint presentation out. Please take a look at this poster. That will help you to understand how good our AgroQual ELISA kit to help you in the validation study. And next, as Professor Wu Yongning mentioned just now on fish, fish is a very, very crucial problem that we're having in allergen for food exporters out of Asia. Oftentimes, fish recall is very frequent. So we actually did a very important validation of fish kit with oyster sauce, with shrimp paste. And please welcome you to actually read these posters later on. And you can see we actually have a very good validation study. In summary, the AgroQuan fish allergen kit is one of the best kit in the market for you to control the sanitizer validation specification for the fish recipe change out. So very important fish allergen kit here. The result shows that it's applicable in any recipe so far in Asia. Even Korean chili paste is possible to use our kit as well to trace whether there's fish or not. And there's no cross-reactivity with crustacea. So this is very, very good posters that we hope to share. Last but not least, if you do validation, we also do rinse water. With the customer sending us, we also compile some of the data here for everybody to know. Very important in fish control because fish is very oily sometimes. So the rinsate to clean it out with your sanitizer, you need to check the rinsate as well. And we publish this poster to help our customers. Thank you so much. And I think that is my last paper. And I would like to conclude with the last slide here. Food allergens are very, very diverse in the market as a challenge for us as food manufacturer. And limited certified reference material, according to Professor Sabine just now, very crucial is that it's very difficult to actually monitor this with a very confirmed reference method. It's still 2 steps away from the reality. And ELISA maybe is an interim solution that is very crucial for the industry to adopt. And last but not least, we believe that close collaboration is very important between food manufacturers and our kit manufacturer, for example, Roman Labs in allergen kit manufacturing. We are the very important support with our laboratory in the region to help you. We have a ISO 17025 laboratory across the continent. And we'll also be able to help you to develop the method like the quantification of LOD for each operational recipe that you want to go after dairy-free claim. And we have been having this knowledge and customized solution in the region for many years, and we look forward to supporting you in the region, especially in China. Thank you very much. And I would like to pass back to the organizer. 谢谢。
谢谢廖经理。那么我们下一位来自于大人的进一步阐述产业界的工作是大人基础乳制品和植物产品的设备面总监 Farah Mafas。Farah, the floor is yours.
Okay.
Farah,
thank you very much. Yes, I am online.
Okay. Yesterday we have met, and today we continue. Thank you.
Okay. So, can you hear me well?
Yes, we can hear you.
Okay. All right. Thank you very much to the organizers of the event and also for the invitation to be a speaker in this session. And I'm going to share about Danone's best practices on allergen management and controls in dairy and plant-based. I will focus it much more from a manufacturer's perspective and just talk about some of the things that we've put into the best practice, which is obviously aided by a lot of the testing and analysis which we have been hearing in the previous talks. And so just moving on quickly, Danone at a glance, we are, I mean, a global company with focused on specialized and essential based and also sauces and beverages. And with I'm sorry, I hear myself. And in our portfolio, we have baby food and infant formula and the yogurt, plant-based product, the waters and I will focus more on the plant-based where we have a wide in the healthy eating new consumption habits. Of course, with this, you have more plant-based ingredients being introduced into the diet, probiotics and immunity ingredients, and then, of course, the essentials and organics, which are becoming more and more popular across our diets. And so with all this, it introduces a wide range of ingredients and a wide range of food products and combinations, which we need, of course, to have a very strong and robust, effective strategy to ensure consumer safety from allergen risks. And with that, I just want to also just go into how then we are controlling this, and it all starts with having a clear allergen control directive, making formal declarations of our safety commitments to the consumer and to the governance, and fulfilling that commitment within Danone. And within this directive, we look at what are the allergen risks, identifying all the sources of allergen risks to the consumer. Secondly, it's the communication. We've heard a lot about the challenges with labeling and what information do we pass so that the consumer can make the right informed choices. And thirdly, it is the whole management of all the processes, the regulatory compliance, the risk assessment based on scientific data, and the whole controls along the value chain. And so we have supporting procedures and tools to ensure an adherence and improvements within this allergen directive. And here, one of the key things, of course, that is so important is this continuous science-based allergen risk identification and assessment. We are following the discussions that are going on, of course, at Codex, where the Big 8 is evolving now, changing. We're having sesame being included, but then also you see in some countries they have the top 10, EU has the top 14, and Japan has also a different list and so forth, as we have heard also earlier. All these differences are important as a global company that is providing all different kinds of food products across the globe. And so it's important to establish specifications where we can link the verification and the monitoring, product release and withdrawal decisions. And in order to do this effectively, we look at various criteria, and these key scientific criteria that we use within Danone is the severity grading of clinical symptoms caused by the food allergy, and individual vulnerabilities, and regional prevalence and knowledge about allergy. This is, of course, a huge difference between the regional prevalence, and this is why also you have either the Big 8 or the Big 10 or the top 14. Potency of allergens also varied within populations, modulating factors such as food processing. How are we processing the food? Is it as a particulate or homogeneous, as we have heard also about detection in the cleaning in the last presentations that we've had. Limits of detection of testing methods are critical to enable us to be able to know at what level of exposures, but also at what level of labeling do we need, depending on what we are detecting and what we are seeing. Allergen exposure, and of course, consumer habits, which are very different across the globe. And so to do this, we also use quantitative risk assessments. And here we are using them in manufacturing and on the market to support the criticality of assessments in incidents or in emergency situations, or where we have unintended allergen presence. The other part where we use the quantitative risk assessments is in our insourcing and in our design. So our procurement of raw materials, our designing of products, to make sure that we can complement the core allergen control program and to inform where we need to have precautionary allergen labeling. So within this, we're using science-based reference dose levels, protein levels from allergenic food, below which 99% of the allergenic individuals will be protected. This is a conscious choice that we've also made to go towards the ED01. And in some cases, we will look at the ED05, but we're looking at this, what are the reference doses that we can use, especially when we look at sourcing, what are the controls where we need to push in order to make sure that we really are reducing the exposure to potential allergens within our products. Modeled from clinical thresholds, data obtained in low-dose oral challenge tests, or derived for each major allergen using vital tools or JEFCA assessments and so forth. It also helps us to define action levels which are giving us a quantitative and a practical rationale on the precautionary allergen label. Also, it helps us to be able to determine where we will, or at what level of contamination we are getting our ingredients, and therefore what extra controls we need to put in place within our own production processes. Then there is, of course, the advanced exposure assessments, especially where there are incidents or emergency situations, and then it helps us to enable to have a risk-based approach overall in the total allergen control program. And so overall, then we have the approach that we would then take for allergen management is a risk-based approach, taking all the input and the qualitative risk assessments. Our allergen management is then an end-to-end process through the entire value chain. Focus in the upstream is to control the risk of allergen introduction into our products. And the focus downstream is to control the risk of allergen cross-contamination to our products. And here, if you look at design, it's about, and sourcing, it's about what can we control to from undeclared allergens to allergens that are identified and assessed. Where there is inefficient cleaning, can we ensure that we can prevent the introduction of unlabeled allergens in our ingredients? And then in manufacturing, it is about from having cross-contamination to making sure that we can prevent or we can minimize the cross-contamination. Where there are no skills or awareness, how can we make sure that there is clear awareness within our production facilities and our distribution or supply chains, that there is clear communication on that. And so if I would just going to touch some of these points one by one. So safety by design, this is really from early on in the project stages, where our research and innovation, our sourcing and procurement teams can mitigate potential risks through risk-based approaches. And here it's really looking at deep dive into ingredients, supply contamination and cross-contamination control, minimize materials with abrasive properties, and then within the formulation, formulation is a lever for claims and labeling information. So it's important to get the formula right. Material formats impact cleaning efficiency, particle size control by line design, and then also the process that will be used, better material handling, dissolving hydration, and air incorporation that helps with better cleanability, reasonable heat treatment design to minimize fouling risks. And so it also enables that cleaning and prevents cross-contamination. Then modifying powder to paste is also a key way to improve and prevent allergen contamination. Within our sourcing and procurement, specifically here, is when you look at the ingredients, is can we avoid raw materials with traces of other allergens? Of course, the challenge is always having segregated supply chains, especially when you look at a cereals supply chain, not always easy to have segregated supply chain, but how can we ensure that we avoid traces of other allergens in our raw materials, abrasive materials I've mentioned, and looking at pastes formats rather than powder for easier cleanability. And then the controls and traceability, something that we've often found is the more you dig up into the ingredient supply chain, when you go up also to the farm level, sometimes the traceability systems tend to be weak. So how do we make sure that, especially when we deal with brokers, blending operations, that we have clear traceability of their practices and also about what they are doing to avoid commingling with other allergenic materials, that transportation is not being mixed up and is also being effectively cleaned to avoid cross-contamination of our ingredients. And that suppliers are subject to variable regional requirements by regulators, something very key to take into account, the regulations that suppliers have to work towards, so that they are also fitting with the requirements that we have for the products that we need to make with those ingredients and with those materials. And then it comes to the manufacturing, specifically here, it's availability of manufacturing assets. It's not always the case that you can have dedicated supply chains. So sometimes you need to use the same line for different products. where there can be introduction of different allergenic materials. So it's now, how do you make sure that that equipment is designed to help prevent external contamination firstly, and to design to make sure that it can be cleaned, easy cleanability. So here it's looking at connections, pipe design, equipment design to prevent splashes, and availability to access different in different ways to validate your cleaning. The factory layout is important, and to minimize cross-contamination, control flows of raw materials, goods, waste, segregation options. These are all very important when you design the factory layout and when you introduce different ingredients that could be allergenic towards one another. And I have to say here, this is something that is very critical also in terms of the communication to the factory staff and workers, to make sure that they understand the criticality of these control flows for raw materials, goods, and waste, as well as the people movement within the factory. Design should prevent allergenic cleaning. Specific choices are needed to avoid material failure. So there's interlocks, program controls, use of efficient digitalization to make sure that you can capture the data that needs to be captured from your processes, and make sure that you are able to make swift changes or swift interventions as needed. Then linked also to the manufacturing is of course, change is the enemy. So whenever you change a recipe, you change something on the line, of course, you need to come back and validate. And we've heard from the previous speakers that need to make sure that you have proper validation to qualify your line, to qualify your recipe, qualify your that it is actually following the requirements that you have set for it. So here it's allergen testing on finished products or key inspection points across your line, CIP rinsing water, batching samples that you have. All these need to be validated and to be checked to ensure that each step of the value chain, wherever we've made the changes, is still in line with the requirements of your product. And not only that you have all the necessary controls to the right level. And sometimes when you do this validation, you may come up to a situation where you may need to change your labeling from free of to may contain, or even to clearly say it contains. Corrective actions are as important, and this is then linked to either production scheduling, CIP parameters being changed. Do we need to have more extended cleaning, for example? Do we need to use double caustic or longer CIP? Do we need more to induce more stringent cleaning, and finding the right balance between the cleaning and the cost, and the timing for production becomes key. And then just as an example here is where the goal was to fully validate allergen cleaning on a multi-allergen line. And in this case, it is milk and coconut, where coconut was defined in one region as being an allergen. And so we needed to make sure that as we introduced the coconut onto this line, that we could still, we needed to validate it properly and make sure we can use the same line to have a milk-based product and a plant-based product as well. So the key areas to look upon was the equipment and infrastructure modifications, shared versus dedicated, and GMPs, the color coding, partner of uniforms, tools and utensils, to say these are the dedicated equipment for the plant-based product versus those for the milk-based product, documentation, the food safety plan, forms for sanitation and allergen preventive controls. And then a key was training, having authorized partners or affected partners, making sure that the staff is fully well onboarded and trained on the differences between having made a milk-only product and now introducing a coconut onto the same line. And then, of course, the testing and for validation and verification of the product and production process. And so just on the right side here, I show where then there was the non-dairy batching for the plant-based coconut, and then the dairy batching on its own. So that's the part of the segregation. And then you've got the fermentation tanks, and then you also have different places to filter to ensure that there is no mix-up of these products. And then in between, of course, is how do you, where the equipment had to be common, how do we make sure that we have the right testing? So there was sampling at every hour, or minimal testing for milk. When you're producing the coconut product for dairy, or dairy for coconut, then you made sure also that you had the relevant testing and segregation as needed. Then the monitoring and verification, I mean, just to go through this one quickly, is so important to ensure robust hazard control. So in having the right sampling protocols, the areas to sample, and also the environmental controls are also important to avoid that spillage of allergen can be carried over to other products. Online controls, the packaging part as well is critical. And then just having good manufacturing hygiene practices is important as well within your monitoring and verification. And then, of course, it leads to the labeling guidelines for consumer information. And it is very important to define the requirements and the risk management actions behind those requirements, and to have a decision tree that enables those decisions and what can be put on the label. And so you'd often then end up with a matrix of where you can label it's free from, may contain, contains, produced in, or produced on. This is usually not something we favor within the known. And so we've put all these in a matrix, and then we can put what are the requirements and what can you use when. And so generally, mostly we would use it's free from, or we would just state it contains. And in those cases where we've done all that we can to prevent cross-contamination, we followed our quantitative risk assessments, then we will be able to say here we need to use may contain, because this is the best way we can inform the consumer about the product and potential allergenic risk. And then, of course, to follow it through into the market, change management in the innovation business model. Now with distribution to new markets, e-commerce channels become more and more important, reusable packaging, all these need to be taken into account also in the allergen management. And this is what we are also doing within our allergen control processes. And then news, social media influences consumer behavior. And it is so important to make sure that we're understanding the trends that change consumer exposure, diets and recipes, and also challenges from consumer actions and consumer boycotts as well is very key to monitor and to understand, because it's influencing how products are placed on the market, and also what kind of information we can give to consumers. Product recall and withdrawal, to manage when you need to pull back products from the market if something goes wrong, and those are very important as well. The human factor is so key. Training and clear guidelines, the people make it happen. So across the entire value chain, we need to make people aware of allergen risk. And also here, just to underscore with my example where we were introducing a coconut into a dairy factory, in most cases, the default was we make dairy. People don't recognize that milk protein is an allergen because this is the default product. But once you start introducing other products into that same factory, it's important to make them aware that the milk is now an allergenic and can cause cross-contamination to the plant-based product, which should be free of milk. So this is important to make sure that staff is highly trained, there are clear guidelines, and they have tools to manage from sourcing, raws and packs, manufacturing equipment, and also packaging controls. So just to round it up, based on our experience in developing transversal standards that is to be enforced globally for allergen management controls, regulatory requirements and requirements are key, and these must be established and based on scientific principles and data specific to the population. So I think this is quite a key point that we have learned, that we need to make sure that we understand the specifics of the populations that consume our products. Risk anticipation is as important as the risk management. And because of all the evolutions and the changes in science and the regulation, like we know Codex now has introduced Sesame. We know that in a few years' time, there will be many changes across the different regulatory texts in the different countries, to either align to Codex or to extend, depending on what their population is exposed to. And requirements must keep pace with evolution in detection methods and the risk landscape. And I could not emphasize the aspect of detection methods much more than we have already heard up to now. And then knowing our consumers is critical to engage them. And so consumer safety needs us to have a comprehensive framework. Carefully constructing this framework to have allergen control is essential for success. Case-by-case risk analysis is still needed with a robust toolbox to prevent and mitigate the risks. So here we use tools that are, for example, in the quantitative risk assessment portfolio, like VITAL. And of course, our people, our ultimate failure or success will lie in the hands of the people that are driving the production of our products in our factories. Thank you. I hand over back to you.
Our next speaker is Dr. Li Guohui from China Food Fermentation Industry Research Institute. His topic today is National Standard for Testing Methods of Food Allergens. Mr. Li Guohui is going to talk about the National Standard for Testing Methods of Food Allergens. Dr. Li Guohui will make the presentation at home, and he will attend the meeting virtually. Dr. Li, are you there? Dr. Li, are you there?
好，下面好，这你就接着开讲吧。我已经介绍完了，忘了开话筒了，所以介绍你没听见。好。
Dr. Li.
好的，感谢吴老师的介绍。
Thank you, moderator, for the kind introduction. Good afternoon, everybody. Thank you for the invitation from the organizer.
也很高兴能参加本次的论坛。
Join the conference, and thank you for the opportunity for exchange and communication, because there is a COVID-19 case in our neighboring community residential quarter, so that's why I couldn't go to the conference venue. And currently, I'm working on the national standard. And today, I would like to share with you the national standard for testing methods of food allergens applied in our country. And I will talk about the three aspects. First is the allergen labeling requirements. Many speakers have talked about the labeling and the requirements for allergen. Is very important because there are a lot of allergen population base, especially for the children's allergies. The prevalence increased year on year, and the allergies food will result in the nervous system and the skin changes, and also digestive system, and maybe sometimes it would claim some people's life. How to ensure food safety and avoid allergen? Meanwhile, we could promote health of human beings. This is the common challenge faced by the whole industry. For the allergen or food safety, there are 6 challenges. The first is the unbalanced epidemiological investigation of food allergy, and the lack of threshold data for food allergen, and the different assessment system is not in place. And also there are different food allergen labeling, and also the processing control of food allergens has some defectives. So there are 6 challenges keeps our food safety and quality control behind. The differences of food allergens and for different dietary structure and different population. For European Union and the celery and sesame are the main allergens, but for Canadian seed and sesame are allergens. But actually there are no detailed food labeling to avoid allergen, and with the label we could effectively indicate the allergen risks in different foods, and the allergen labeling requirements in different countries actually are different. I will not talk into details, and here I would like to mention about the allergen labeling requirements caused by cross contact. Okay, the best practice is provided in 3 parts. The first is the statement of ingredients. A special fonts should be used in the statement of ingredients to provide detailed information so that we could enable the effective control. And also we need to summarize there should be a summary statement and a precautionary allergen labeling statement with the potential allergens. This is voluntary, so the 3 factors can be used. And in China, the allergen labeling requirements are introduced by Professor Wu. A standard of allergen detection methods in China are needed for standardize the allergen control. Just now, a speaker talked about the EU standard. And now I would like to review the Chinese standard for allergen detection methods. We have only the entry, exit, inspection, and quarantine. Other mandatory national standard and recommended national standard and other industry standards are absent. And for the inspection, there are qualitative and quantitative testing. Qualitative testing is just the same as shared by other speakers. The enzyme ELISA or the RT-PCR method and the LAMP method. In China, also we use the visual biosensor chips for testing, but for the quantitative method, in China we use the LCMS method. That is the SNT5276. All these methods are demonstrated in SNT 1961 detection of allergen components in food for export. Actually, 18 allergen tests are adopted. And this is the PCR, the quantitative test is used, but for the peanut ELISA, and also the ELISA for the buckwheat protein test is also used, and the detection rate, the range is between 0.78 nanogram milliliter to 50. And the detection rate is about 0.01%. This is the testing capacity up to now, but what deserves our attention is the celery allergen testing. That is the nanogram per milligram. And the second series is SNT 4419. It is based on LAMP methods for export. That is, 22 allergens are incorporated, which corresponds to different allergens. The systematic method for allergen detection, the detection rate is 0.5%. Compared with the 1961, the capacity is not as good as the previous one. Another is 4417. It is based on the Weizhou biosensor chips. The standard specifies the Weizhou biosensor chips detection method for 8 common food allergens, including soybean, peanuts, wheat, cashew, cattle, fish, chicken, and shrimps. Its advantage is it is quick, and its LOD is 0.01%. The only quantitative testing method standard is SNT 5276 in 2020. This is the LCMS method, and the standard specifies the liquid chromatography mass spectrometry MS detection method for allergen proteins in milk, eggs, soybean, peanuts, and nuts in processed foods. And hazelnuts, walnut, and almond are the major categories, but for allergens, milk, eggs, the qualitative LOD is 5 milligram per kilo, but for allergen materials, peanut, soya, and 3 nuts, the LOD is 10 milligram per kilo.
Based on these features, the quantitative method can also quantify based on the strength and the relationship of the allergy and the allergen. And just now I've mentioned about the research of the allergen research. And now I want to talk about the standard demand and developmental trend of allergen. For China, generally speaking, for the testing and the research, we are a latecomer. We still need to further improve the system. In particular, the allergen labeling became mandatory, and definitely we need the improvement of the allergen detecting methods. Or we also need to test the current methods, especially for the different processed food. We need to know the impact on the food. Besides, the trend of the methods is not only about the qualitative one, but you should move towards quantification. In China, we don't have a lot of allergen evaluation and testing data. There's a strong need of allergen test. It can help us to predict the possible allergen of some vulnerable groups. Some new technologies in the future may also be adopted or used in the new standards. In addition to the immunological methods and the MS methods, some other new technologies such as biological chips methods can also be considered. Yet we need to evaluate the differences of different methods and their efficacies. In particular, for the immunological methods, it is not targeted at some specific allergen, and there are some variances as well. Previously, Mr. Wu and Dr. Li Dawei mentioned that for a certain food, there's a strong need for standardization. For the gluten food, we already mentioned that for the allergic people for gluten, I think it's related. It's just a whole process, and there's a large population who are allergic to gluten, and a lot of studies and researches overseas. Yet in China, only Shandong and Xinjiang has some research led by Professor Chong Jun. While in other countries, they have some verification system, and also they have a lot of gluten products, gluten-free products to help this allergic population. But in China, we don't have a standard guideline. Mr. Dawei also mentioned the differences of the testing methods of gluten allergen. In particular, it is demonstrated in the systematic evaluation results. For this allergen, the requirement is not to tell if it's positive or negative. It's more about its quantity. It's more about its limit. Therefore, we need to have very precise and quantitative testing methods of gluten to resolve such an issue in China. Last year, we started to draft the gluten-free standards.
As I already mentioned, that now in China we don't have a unified or harmonized gluten-free food testing and detection methods. Now we are discussing the guideline. We hope that in October, in Guangzhou, we can continue to promote the formulation of the standards for gluten-free products. Besides, I also want to say that for the detection of the gluten methods, there are a lot of methods. Generally speaking, for the ELISA method to detect gluten, as it has a different isotope, the different methods may have their variances for the different processed products, and the results may differ from each other. However, Mr. Zhang Dawei's report also clarifies that these differences can be mitigated. To a certain extent, they have more similarities, and they are equivalent to each other in the testing results. Another method is the LC MSMS. We are also working on it, but we don't have a lot of references. And also to tell the features and the characteristics, we don't have a very unified methods that pose challenges to our efforts. All of these are the practical issues faced by us, and that should be the priority for the allergen detection methods. Therefore, I really want to urge the experts and the guests to follow the research of allergen quantitative detection methods and to promote the improvement of the allergen standardization. We need to further promote the risk evaluation of energy and to better help the regulation and the monitoring. As for the allergen system, standard system, there's a rough framework from our perspective. And also, we learned from the advanced management system from other countries. We think there can be the basic standards and management standards, and these are two major components. In terms of the basic standards, it should include terminologies, the signals, size, the evaluation standards, followed by the glossaries of the basic allergen, and also the glossary of basic management. And besides, we also want to have the unified standards of the symbols and the size. In terms of the allergen management, we want to divide it into general standards, product standards, testing method standards, and the production management methods and standards. And below that level, for instance, under the general principle, we can include the pre-packaged food labeling general principles and the food allergen management, etc. For product standards, we can divide it into the common or the brigade allergen standards and also other allergen standards. For testing method standards, in addition to the methods itself, we should also establish an allergen testing technical standards for the production management standards. It should include that the whole productions process from the perspective of allergen, and also the operational standards to avoid introducing allergen. So that's our rough idea for the whole food allergen standard system. We hope to better regulate the market and to minimize allergen risks. Okay, so that's all from my part. Thank you so much. Thank you. Just now, I have already said that the expression itself is pretty good, 过敏源, and also the word in itself is not good. And so I think for the standard practitioners, you need to have the unified expression. And also, I think that we need to follow the instructions of the National Terminology Committee. All the glossaries will be issued for this area. And so I think that we can rename it to the 知名源. And actually, the word in itself should be correct in Chinese character. And I hope that you could be very accurate in the word choices. And in the standard, that's very important. Now, let's give the floor to the next speaker. And we will have Mr. Wang Liang, who graduated from the Beijing University of Science and Technology. And now he is the Chief Technology Officer of the Roman Labs in China. Now let's give the floor to Mr. Wang Liang. Good afternoon, ladies and gentlemen. First of all, I want to thank Mr. Wu and also for your introduction, and I also want to thank Dawei for your introduction. Roma Labs have been involved in the testing of allergen for many years.
And many communications are conducted, and I hope with their presentation we could share you with some information. My presentation consists of 4 parts. First, the introduction of allergen and detection technology and categorization, and as a business and how to effectively control and monitor allergen. And the fourth part is the problems and our discuss and arguments. And currently we have many insoluble problems, but we want to share with you some communication, and this is a quotation from CIFSQ. And what is food to one is to others bitter poison. This word is why we pay our attention to allergen. But for some population, and the food can be a poison, so that's why allergen is what we need to concern in the food industry. And then the side effect of food can be categorized as 2. One is a non-toxic food, and another one is a toxic food. For example, the pathogen and some toxins. And but for the non-toxic food, they would not harm human beings. And to categorize, and first is the IgE cell mediated And another one is a non-IgE cell-mediated. For example, the celiac spruce, and for the non-immuno intolerance of a certain food, and for example, the glucose and the gluten allergen. Such kind of allergy is will not show any fast reaction, but later they will impact the human health. And some allergic or say the acute allergen may occur, and currently we have found that more than 160 foods could cause allergy. So there are a lot of reports about allergen, and the direct influence is the it will result in some inflammation, and which can be fatal to human being. So this is the what we call the allergy caused allergen. And allergy, how to avoid allergy, that is to keep you far away from those allergen. And do we avoid such kind of allergy by preventing consumption of the allergen? But where are the allergen come from? And first is from ingredients, for example, milk and peanut. And in many packages of food, the instruction could indicate that the ingredient of allergens there can be caused by the cross-contamination in weighing, mixing, production, and transportation. So we need a mechanism, a method to prevent or control the allergen source. And these are some commonly seen testing methods which are introduced by many speakers. I will not go into details, but I would like to share with you some information. The testing methods can be categorized as two. The first is the fast analysis, and another is equipment analytical method, PCR, LC-MS, etc. But the equipment analytical method is not an arbitrary method, because allergens do not have an official arbitration protocol. So actually it is one of the methods can be used together with the rest. And with the testing strip, we could test the allergen as positive or negative. The ELISA test kit method, including sandwich and competitive methods. Usually the sandwich method is used. The PCR method is to extract the DNA and expand it to obtain the quantitative result of PRC. And what are the advantages and disadvantages? First, LFD and PCR methods. And the allergen protein will be tested, and of course the ELISA method is easy in use and easy to be carried out, and also it will be influenced by the sample mechanism. But LFSC could enable very easy operation, quick result, and sometimes it will be infected by some foreign substances, but DNA is highly sensitive, and sometimes with the foreign matters we may get the quasi positive result. Of course, method is different. Actually, sampling is also very important, especially for the protein-based testing method. For example, Romer, about 3 or 4 years ago, tested the fish meat with a test kit, but it is not the failure of the testing It's not because of the strip, but the extraction didn't give us a very effective sample. So the sampling is very important. How to obtain a representative protein and keep it to test it positive. And this is a very key process. And this is the LFD and PCR comparison. Another is LCMS detection, and whether it is a future trend. And maybe we understand the PCR theory, that is to unfold the sample proteins and with enzymatic cleavage of proteins, we could realize the result. And what is the advantages of the LCMS method? And for the mycotoxins can be tested at the same time, and their sensitivity is high. And also we could test the various peptide markers. So the reliability and sensitivity are high, but the equipment is more expensive, and the analysis can be complex, it time consuming, and also we didn't have an unreliable detection method. The four methods are compared in my presentation, but for me, I would say we don't know the allergen detection direction or where will it go, but the protein and based detection is the most effective one. So this is the introduction about the method. And the third part is the allergen contamination risk control. Speaking of this issue, it cannot be realized by a single manufacturer or an institution, and all the sectors need to make joint efforts in operation to minimize the contamination risk. And for example, the manufacturing, the quality control, R&D, sanitation links may make a difference in the process, and how need the enterprise to manage the allergen. And also we need a process diagram to identify the contamination points and place our attention to it. And also we need to define the factory specific allergen control plan. Previously, we have customer manufacturer in the allergen control. The gluten contamination risk is very high, so they need to monitor the gluten mixing process. So they need to define a factory-specific energy control plan, and also they need to regularly review the allergen plan and update it, because the technology and process are changing, and we need to assess our allergen plan when necessary in control and prevention, and what are the key points we need to monitor. And firstly is R&D, and we need to consider whether an allergen need to be added. Sometimes the allergen is necessary, sometimes not. So it may pose risks, so we need to consider whether we need it. And then the sourcing of ingredients. The typical practice is to label different materials to differentiate the allergen from non-allergen. For suppliers, we need to require them to provide a report about allergy and tell us the control measures they adopted. And then we need to avoid cross-contamination in production, and then the packaging and the labeling review and the legislation, etc. And also we need to assess the cleaning process. Some manufacturers could produce the products with and without allergen, and they produce cakes or beverages, and they need to carry out a very effective cleaning procedure. And another one is about the staff training and education to raise their awareness to prevent cross-contamination so that we could minimize the allergen risks. The 3 steps can be tested with some certain detection method, and in avoiding the cross-contamination and the cleaning process, we need to assess the final result and what samples are used. And first is a solid sample, and that is the food finished product and or the ingredient, and then the rinsing water to see whether the sanitation process is effective, and then the environmental swab to test the surface. The first one is the ingredient or the sample testing, and the last one is environmental testing. And I want to share with you the final point is some problems in testing or detection. First is allergen testing mechanism is very relevant to testing results. The matrix effect 1, for example, the 20 ppm walnut can be easily detected in biscuit, but in chocolate is very difficult. That is because the fat or say some chemicals, etc. And another is a matrix effect 2, and the extraction recovery rate and extraction rate can be very different in different samples. And for example, after heating and some allergen can be hardly extracted from carbohydrate. So after processing, maybe the extraction can become very difficult. And also in processing, the protein can be changed in nature, and which result in the different detection results. So maybe you would believe those are the difficulties in testing, but what I want to emphasize is that enterprises in choosing an allergy for the control need to keep effective communication with the manufacturers. Manufacturers could help the enterprises to develop the appropriate method for testing, and we have 5 ISO labs which can define or design very effective monitoring, and then the choice of the allergen testing program, and for example in the allergens in milk, and what products can be used, and for example the casein, the beta-lactoglobulin and lactoglobulin, wine serum, albumin, etc. be used. And then the testing capacity assessment is also very important. Just now, different testing methods can result in differences of the results. The for pass ring trial result, that is for the peanut in chocolate, and different manufacturers can get very different results in testing.
This is the sample of the FAPAS allergen capability test. You could see that compared with the traditional samples, it's different because it's tailor-made. And for the different producers, after customization, the value can differ greatly. And for this one, you can see that the maximum value is 15 ppm. Therefore, we believe that you need to focus on the labels or the manufacturers. Besides, I also want to say that for allergen test, it should target at certain products. Our clients said that after the ATP, cleaning or the surface operating for environment testing, whether it's necessary for the allergen testing? The answer is yes, because the traditional clean testing cannot replace allergen and test for the surface protein. And the precision is about 3 milligrams. And actually for the allergen and test, the sensitivity is much lower than it. So definitely we cannot use the environmental testing method to replace allergen test. Besides, I also want to say that in choosing the swaps, we hope that you could choose the location that is most highly polluted. Besides, the sampling tool is also very important because it needs to collect the allergen protein. And some of the swaps are not suitable. It may have the false positive or false negative results. And besides, for some of the swaps, they used they were reproduced by the milk packaging boxes, and the result might be positive for milk. So we really need to pay attention to that. That's all for my sharing today. And we also have a booth in the hotel. And also we have a roundtable discussion later. I'm looking forward to talk with you. Thank you so much. Thank you. Now we will move to the last session. We will have the roundtable discussion. Only Wang Liang and Mei and I are on site, and I don't know whether Martin is still online.
I am online. I'm online. Thank you very much.
Anyone else who is online? Yes, I'm also online. I'm Yong Wei.
Check the chat, what question is online， 看看那个聊天室有什么问题。每位在网上的各位在。
So for every one of you who are online, feel free to ask questions via chat. Maybe we can show the questions. No questions. Then what about the floor? Any questions from the floor? If you don't have any questions, I may go ahead.
Then we just you see for mentally labeling and just for the WHO consultant meeting this year, and CIFSQ have replaced to soil bean for big ed. What opening for all the panel? What should we do for the CIC? Will be still the big ed or 9 ed? I understand the EU, Canada, and Australia and the US all have added the assessment. So we are should be big 9 or not big 8. Maybe we can start with the Martin.
Sure, I think you can hear me.
Yeah.
So I actually, when I saw the summary conclusions of the commission of the expert panel, actually, I have to say that it was not as much of a surprise that soybean was not included. This is something that in at least the past I would say 5 years have been already under discussion between in the scientific community whether there was enough information on prevalence to support the inclusion of soybean or not there. And definitely the information doesn't seem to support the same importance for soybean. Yeah, so soybean has been introduced originally, as we saw already, in 1999. But the availability of data there, in particular of prevalence and of how potent the allergens were, and the kind of effects that they would elicit in the allergic population, was much more limited than the one that we count right now. And so the information that they have used, the commission have used, is based on double control placebo. Essays mostly. We are talking also about oral challenges. So that's the golden standard when it comes to testing for food allergens. And again, all the information that we have right now goes into a direction that seems to support, or better put, not to support soy as one of the major aid. So I would definitely not maybe talk about 9 when it comes to a global perspective. Nevertheless, I think it's also really important to make the remark that also the commission made, and is the fact that there are big regional differences. This is something that is also known, that it has been known also for many years, and that the allergens that might be of importance in one area may not be from the other. So when it comes to regional, then definitely we would be on the, facing not only 8 or 9, but many more allergens, I'd say. So my approach would be not this of trying to become like 9 to get 9, the big 9 or something like that, but really to try to produce relevant clinical data that could support actually the inclusion of other allergens on a regional basis. Yeah, I hope that that answers your questions. I don't know if someone else would like to add something from the panel.
Sabi, what are your opinion? Okay.
So I just want to add from the analytical point of view. In that case, we will never talk about the big 8 or the big 9, because we are looking for all the allergens which are relevant. And I think, as I only can underline what Martin actually has said, there are also a lot of differences between the countries. So I'm not quite sure that it will be a worldwide number set for the big 8 or the big 9.
Okay. Thank you.
Maybe just one more comment before. Maybe just one more comment before. There's also one very important thing to do. I think it was mentioned during the session. I think Sabine, you mentioned this before, and it's the fact that we need to make sure that whatever regulations we put in place aligns with actually the technical capabilities, methods of analysis. Sorry, this is something that we have observed in the past. For example, with celery, in which celery is regulated, and nevertheless methods of analysis that are appropriate for celery were lacking. Yeah, so this is a very important point to address before. One example is, for example, carrot in Central Europe. Are we supposed to now develop methods for carrot? It's about to be regulated, for example. Is the industry ready to provide with methods of analysis for carrots? And are those methods sensitive enough? So these are all considerations we need to have before we focus on 8, 9, 14, or the inclusion of any new allergen on a regional basis. Sorry. Now, I think Farah, Dr. Maposa or Yongwei, you wanted to say something?
Yes, for Singapore, in regulation that we know of, is already listed soybean as one of the allergen that they are looking at. But on behalf of Australia and New Zealand country in Asia, soy allergy is actually in the increasing stage. So it's been a population-driven clinical data that drive the regulation. So I think the global perspective followed by local perspective at the country level, clinical data is very, very crucial. So I would see that it's between 8 and 9 at least. Yeah.
Okay, Farah?
Yeah. So it's always a difficult subject. Should you go for 8 or 9? But I think the key point would be, how do we make sure that we can protect our populations from allergenic risks? And there are different regional characteristics that need to be taken into account. Obviously, the diets we have is also playing an influence into the way we are exposed to allergenic materials. So even though from a global perspective, I mean, Codex says we can take soy out, we still need to keep it in the radar to make sure that we still can protect those that are having some susceptibility to the soy allergenic proteins. And also to make sure that, you know, we can inform consumers appropriately, because obviously where soy has been considered as an allergen for all these years, how do you make sure that we give the right information to consumers now when we say, oh, we take soy and we bring sesame as a big 8 or big 9. So I think it's really going to come down to what is the exposure of our population and what do we need to put to protect our population in the either regional scope or local scope.
Okay, second question. Just you see for the allergen leveling strategy, originally all of your country is mandatory, and in China we are now was voluntary, but still China will be take two strategy. One is the big 8, whatever, should be mandatory. Others will be as the 把它变小了，别把它们挡了，放在这个地方。China just we have the big 8 as a mandatory, what like, and other things just voluntary. What's your comment? What we should do? Okay, maybe the Farah?
Okay, I can start. So I think my first thought is that what is important is to ensure that whether it's mandatory or voluntary, that we can inform our consumers and give them the right level of information in a very simple, understandable way. And I think what would be really good and key would be to push for a harmonization as much as possible globally in the way we pass this information to consumers. So if we can follow, is it by making it bold? Is it by stating clearly? When can we really having guidelines that are more harmonized about where can we use may contain versus contains, and sort of what sort of texts can we use? Because today, I think the challenge of the labeling is because either it's being used to say made in a factory that also makes something else, and that's how should the consumer understand this kind of message? So I think one of the things that for me would be key is how can we make sure that when we ask for labeling, that labeling is as clear and as simple as possible for the consumer, to make sure the consumer is well informed in a very simple way. Simplicity is a key point for me. And then secondly as well, how can we harmonize it across the different regions, not only for China, because you can imagine with a global world, products are moved from one region to another and sold across different locations and regions. How can we ensure that, you know, we are also moving towards, you know, similar ways of labeling and statements that can be used for labeling? My last point is, whether it's mandatory or voluntary, we need to continue pushing food safety management systems and allergen controls to be robust, and that labeling should not be a way to get away from good manufacturing practices or good cleaning practices. And I think that's what we need to ensure that labeling is avoiding. Yeah.
Okay, Xavi?
Just a short comment also on that. I think it is a good way to start like that, because as you can see also in Europe, the list was amended. So we started also with the first aid mandatory, and then we added as soon as new things are coming up. And you can also see in Europe, we have salary there, and probably in China, there will be different things which are not concerning European consumers in that case. So for if you have the national legislation actually for China. So I really think that's a good way going forward, and there will be amendments, a lot of amendments, I think.
Okay, Yongwei.
Yes, from Asia Pacific, right? Many of the regulatory we speak to, they actually propose that the consumer should have a choice. They have to read the label. In fact, some countries are training consumer to read the labels. As long as you mentioned that it may contain in a factory producing together with peanut, then you need to know that the parent for a peanut allergy children, the parent shouldn't buy the product for the children. So it's very crucial that we actually, like what Farah was saying, we should give the consumer the full information and let them have a chance. Otherwise, they'll get into trouble for the children, especially. Thank you.
Okay, and we have the online question. Just maybe we ask David Zhang, and we talking about the gluten as the allergen. But how we can define barley, wheat, and the chow mein? What's the difference? Allergen, you can define. 荞麦、大麦、小麦的不同之名。
Oat, barley, and wheat, can they be defined as they are gluten allergen?
因为就是关于这个无麸质的。
For the gluten-free definition, we need to refer to the definitions of Codex. That is to test them by toolkit, and then the content should be less than 20 pp, and some say gluten-free or low gluten flour after treatment, and the content could be lower than the indicator. So we could define it as gluten-free. And for example, the oat is removed from the list, but for manufacturers or businesses, we don't need to care about the definition of gluten, what protein it is categorized, and we could use the toolkit, test kit, to define it as gluten-free or not.
Okay. Some question for Martin. Martin, can you have online?
I think I have solved my problems. I got offline for the past like 5 minutes or so, so I've lost a bit of the conversation. I jumped back in when David was talking about gluten. So if I understood what the question, what about the definition of how to approach wheat, barley, rye, and gluten, right? I'm not quite sure because, as I said, I got in the middle. So the only thing that I would like to comment here is maybe that we need to consider that gluten, I mean, we have several ways of defining it in a historical perspective. Gluten was basically a defined proportion or a defined portion of proteins, storage proteins that were not soluble in sodium chloride solution or water. And so if we go for this definition, oats should actually be considered as containing gluten. But actually, I think that further studies and more well characterization of the proteins contained there have shown us that it is not the case. But the gluten that is problematic for for the health of individuals is basically the ones coming from wheat, rye, barley, and hybrids thereof. There's still a bit of controversy regarding oats. In most cases, it's considered that the gluten that is contained in oats comes from cross-contamination. So just a bit of a controversy there, but the consensus is quite rich now regarding that oats not containing gluten. So this is also in particular of particular interest maybe for the industry, since in many cases the industry keeps using the word gluten in the traditional sense of proteins, so storage proteins, and therefore we can find products saying gluten from maize, for example, that corn gluten, which is quite funny, since corn is one of a product considered as gluten-free and therefore used for as a base for the production of gluten-free products. Yeah, so that's one thing just to take into account, that even if we focus on barley, rye, and wheat, the content of the proteins that we will have there of gluten is quite different, and the methods of analysis that are developed usually use one or a mix of antibodies that are detecting the one or the other gluten. That means from, for example, rye or wheat, then all of the others are basically detected by cross-reactivity. So we have several problems here. So as David said before, we have the definition from Codex that tells us that gluten should be considered like 2 times GLAD in content. And this is also problematic because further research has shown us that this is not really the case for most cereals. That is not even for wheat, not even for all the varieties of wheat. So it's quite a complex problem, I'd say. The definition itself, so to say, one approach could be, for example, to focus on a mix of the varieties that are of relevance for the regions. That is something that has been done in the past. It has its pros, it has its cons as well. So I think the best would be to actually try to define where the contaminations come from, to have the most information as possible from the samples when it's trying to analyze, and most importantly, to know the limitations of the method one is applying. That is to say, if it's detecting wheat, for example, is it detecting rye or barley, and in which, with what kind of recovery? This is quite challenging, I have to say, from an analytical perspective. And maybe just one extra comment is the fact that so wheat, for example, has many other proteins that are allergenic. Yeah, so gluten in itself is you know really a compound of many proteins, some of which are in fact also allergens, many of which are not allergens. So maybe just to make a distinction that when we talk about gluten, it's something completely different of an allergy. And in many cases, this is a bit lost in the analysis, that we focus on gluten and we forget that there are other proteins from wheat, for example, that are allergens and are not being addressed. Yeah, this is also valid, of course, for other cereals as well. So again, this is just a comment on my side. I hope I have addressed half of the question I heard. So thank you for the opportunity.
Okay, and you see for the gluten-free certification, and we need a stand. Almost the CIFSQ stand in the short ball. I will be leader the draft group on to the national stand on gluten-free. The maybe 20 the service is okay, but just CIFSQ stand depends on one company testing. And just like David Zhang have mentioned, we have the, we call the G12 and the I5 protein. And also we have LYC mass and the ACCES mass. They have the different strategy, and almost if just the ELISA mass or the Lottie mass, that the immuno mass almost depends on company developing the antibody. And but you see, according to China law, we are, if the government regulation, we cannot depend on only one or two company antibody. That how can we do? For example, we can have Roma, then we need the new gene, we need quite a lot of company to combine to get the we just wonder how can we do Sabi, what is your opinion?
As you can see from what I've told about the existing standards, actually, in my case in the European Union, especially for the ELISA kits, you have seen that there are no standards out there because they are all commercial ones. So I think if you want to have a kind of that standard there, you need to go for you need to publish the antibody, you need to publish a validated method with that antibody, which is not commercialized actually. So that would be in that case the way to go for, if I see it from the scientific point of view. But I can't answer that how the companies would see that.
Okay, maybe we can ask the Wang Liang, and if according to ISO 17025 for the laboratory, how to validate it, single validation, and how can we do collaborated validation on this test method? Because if we have the national standard, then we have surrogate on the test on the limit. Then we should have the consensus method to test that.
This question, okay, I will try to answer it. Maybe last I would ask the lab colleagues in the third-party lab, what methodology do they use to test allergen? Their customers usually ask them to use what kind of products for the testing. So this is the situation faced by the third-party labs. And for the different allergen product selection, they have their own way of assessment. Currently, we don't have an official methodology to assess what product could be used for the testing. And different companies would define the values for assessment. In Romer, when they're using our testing, and they would ask us, they would use our template to assess their capacity. And okay.
其实就是关于这个过敏。
Regarding allergen testing, we do have some cases. One client sent a sample to us, and the mechanism is quite complicated because they want to test multiple allergens, and they send it to our Austria lab, and they said that 3 are below the ALOD, 2 are NA, and asked them what is NA, not applicable. That is to say, when they have done the testing and labeling, but for the other part, it has not been done, and so they have not validated that mechanism. So they can only say the result is an A for certain allergen, because for some, if the samples are processed, they are not able to identify the antibody, or due to the intervention of some mechanism, the result might be false positive or false negative. So for the internal lab, you need to be very careful. If you say that it's non-contact, when you export it to EU, if it's tested in EU, they will think your labeling is problematic. Besides, I also want to respond to what Mr. Wu mentioned. If internally for your validation, it's quite easy. Firstly, you need to do the linear testing. However, it's not easy for you to do the marking solutions. And so they normally send it to the labs, and they will also use a marking for it.
And to Europe, for the Asia Pacific, especially for East Asia, what do you offer?
Sure, right. The customers that we encountered had the same challenge that what David was saying, Dawei was saying. So very important, I think the reference standards as we spike the samples is very crucial. That will ensure the kits are operating within the limits that we're talking about. And many times matrix interference do have an effect on this as well. So in our laboratory report, what we do, especially for food allergen report, we are very, very careful. In fact, once the material comes in, we will actually begin the spiking, do the LOD limits of detection to see whether we can actually detect it. Then we can conclusively say that we can publish the report within the limits of quantification and limits of detection. Today, as we talk about, many customers, when they approach us in the laboratory analytical report, what they want to know is that, can you tell us the LOD? So we can see that the allergen industry is moving towards a limit of detection, understanding whether the kit is working for them. So this is my input from Asia Pacific customers that we engage with.
Okay. For the Roma, Martin, for the European or all the Roma, what should to do from a single laboratory to all your Roma system? Martin?
So yes. Again, I don't know if I'm having audio problems or what. I only partly heard. Could you please repeat the question? You are asking me something about Europe. I'm having troubles listening. I'm sorry.
Okay. You see, for talent or industry, how can we choose different convention test kit? Farah?
Yes, so it's a good question, and I think definitely being able to have standard methods is key and is super important. The challenge when it comes to allergens, of course, is the product matrix, and this is where, when we approach our partner labs, we are always asking, do you have the test validated for our matrix? And then it's a process to go through the validations. But I definitely will say, if it would be easier, somewhat easier, let me say, if we would be able to approach any lab and ask for the same method, and they are using either the similar set of kits or backbone to their analysis as the other lab. Now, what tends to happen is that you then end up working with one lab, and they develop a test for you. And in case of changes, and that lab is not readily available, that can be very challenging as to how then you deal with your product on that moment. So, I mean, for sure, I couldn't disagree more with what was mentioned earlier, to say, there needs to be a way for us to share the technologies across, especially where things become mandatory and should be labeled. It would be good also to say, how do we then come to having one standard that can be used by everyone for those allergens that are really common and key everywhere. And then maybe for the ones that are newly developing, newly coming up, the process needs to mature and develop and it can go like that. So that would be my contribution to this. Let's have a standardized ones for all the things that are common, to make sure that we can use different labs, go across different partners where needed, or across different regions or countries. We will need still to do specific validations for our specific product matrices. That needs to happen, but a good starting point would be that harmonization and that commonality on the things that should be common already by now.
Okay, final, just from scientific view, Sabi, what are your opinion?
Actually, there's nothing to add. So I think the great thing is when we have a look at that, so we have international transdisciplinary connections we have to do here, that we can get exactly to that what Farai already said, that we have open methods to have a look at, to work with them, that we get the same results. And I think we are on a good way to that. As I've already said, we started with the with how do we call the values we come up with? Is it milligram protein? Are we talking about ppm? And I think it is a good way we are going to harmonize when we're talking about allergens, food allergens.
Okay, thanks all the panelists. 我们今天
I think we have a very long day today. We have a very colorful panels and presentations. Personally, I think at least for the past 3 years, every year we have a lot of differences, and also we have a lot of different input to the audience. From China's perspective, we can know that the standards are changing for its whole process, from monetary to monetary, and to the gluten-free standards, and to the dual track, etc. While internationally, they are discussing, in addition to the bigger 8, they may replace soybeans with sesame, or make it into big 9. And also there's some other wonderful results. All in all of these decisions need to be based on science and evaluation. And in the end, we will have the science-based and Chinese people or Chinese population-based risk evaluation. And based on the allergy of the Chinese people, we could find the labeling system that's suitable to the Chinese people. And also, this year we also talked about the CSC's production standards, or GMP. And also Roma Labs offered us a very comprehensive presentation regarding testing, etc. And also want to thank the Professor Li, as well as other participants. That's the end for today's meeting. Thank you all, and also want to thank the sponsorship of Roma Lab. Thank you again. Okay, that's the end for today's meeting.
Bye. Thank you.
Yes, yeah.
Goodbye, everyone.
Bye.
Bye-bye.